Hello everyone, welcome to Bloom Lessons. I am Brian Andere. I'm a software engineer currently working on DevSecOps. And in this tutorial, I'm going to take you through how you can set up a Kubernetes cluster on AWS. This will be a self-managed cluster and we'll be installing it on the AWS infrastructure. This tutorial will be split into 6 sections. We'll start with the introduction, then we'll do the infrastructure setup, the Kubespray setup, then we'll install our Ingress controller, install the demo app, and then we'll jump into the conclusion. Our aim is to install a cluster on AWS. We'll be using 3 nodes, 1 master node and 2 worker nodes. Our end goal is to successfully run a sample application and access it on our browser using public internet. We'll be using Terraform to set up the infrastructure, Kubespray to install the Kubernetes components, Nginx as our load balancer, and HA-Proxy as our Ingress controller. You need access to an AWS account. You need to have some Terraform knowledge, Docker knowledge. You need to know how to use Helm commands. You need access to a registered domain, Ansible knowledge, Nginx server setup knowledge. You need to know how TLS certificates work. In this tutorial, we'll be using acme.sh to generate our TLS certificate. And you need to know how to apply Kubernetes deployments and how to check if the resources applied are working correctly. The mandatory items here are access to AWS account. You also need access to a registered domain. That's mandatory, but the rest you can learn along. What's the roadmap? We'll begin by creating an AWS account user. The assumption here is that you already have an AWS account. If you don't have one, you can go and sign up for an account. Item 2 will be to create a Hostedzone where we'll create our wildcard subdomain for our Ingress resources. And then we'll create a VPC with the private and public subnets for our EC2 instances. Kubernetes nodes will reside in the private subnets, and then our load balancer node and our Bastion Host will be in the public subnets. Then we'll have EC2 Instance Connect and the Bastion Host for accessing the instances in the private subnets. We'll also have some userdata scripts on our infrastructure as code setup. We'll configure and run Kubespray, and then finally we'll install our Ingress controller and set up our sample application. To get started, for the infrastructure setup, we'll begin by creating the user. You have 2 options. You can either decide to create a user with minimum access, or you can decide to use the user with a policy named administrator access. So with admin access, this user can have access to everything, although that's not recommended. That's why in this tutorial, we are going with the minimum access option. So let's just review the policy for IAM. Since the rest of these policies are AWS managed policies, the other policy that we'll create will be the IAM policy that will be a custom inline policy. This is how the policy looks like. We have the read permissions. So for this user, we'll allow them to read everything on IAM, but depending on your organization needs, you can limit this further. Then this user will have permission to create and delete their own access keys, and also upload and update their public SSH keys. As you can see, the resource is limited to only the current user on whom this policy is attached. And then the last policy is where we'll do some update later on, depending on the name you'll use for your Terraform setup. So you can see here we are allowing this particular user that this policy will be attached to have write permission to fully manage this user. This is the user that will be used in our setup to generate the TLS certificate and add DNS records for the certificate renewal. And also this is the same user that will be added in the load balancer instance to allow acme.sh to automatically renew the certificate when it's due. Now to set up our IAM user, you need to log into your AWS account. So we'll just sign into our account. You can use the admin user or your root account to create this new user for this tutorial. So once you log in, navigate to your IAM console. You just search for IAM and then open. On the left panel, that's the left sidebar, go under Access Management, click on User Groups so that you can create a group for this particular user. User groups are important because they'll allow you to share permissions across multiple users instead of attaching policies directly to a user. So you can create a group. Our group will be named Gates Tutorials. And then under permissions, we'll add the AWS managed permissions first, and then we'll finish with the inline policy. We need VPC full access, need EC2 full access, we need also Route 53. Finally, we need S3 for Terraform. And then you can just create the group with those. Our group is created right here. Open the group. And then now under permissions tab right here, we are going to attach the additional policy for IAM. Just click on add permissions, then create inline policy. We won't be using the visual editor, we'll be using the JSON editor. So now we have our JSON policy pasted here. So this is the first section for read access. This is the second section for write, user specific write access. And then this is the last write access we need. Once you do that, click on next. You need to give our policy a name, and you can give it a more descriptive name, but we'll use this one for now. Custom inline policy 1. Since we finished our group, you can see the group doesn't have any user, so we need to create our user. On the access management on the left sidebar, click on users to open this user page. Click on create user. Our username will be create tutorials. Then you'll provide access to the console, and then we'll be using the IAM user. Make sure you select auto generate password, and then select users must create new passwords at their next sign in. Click on next. It will prompt you to select the group for that particular user. Select the group that we created. Click on next. You can review the information we just entered. If it's okay, then click on create user. Once the user is created, you need to download the first time login credentials. We'll use that to set up the user. You can return to the users list, and you can see now our new user is added as shown here. Now we can log out of the admin account. Open the CSV file. So from this CSV file, you'll find the required credentials, the username and the password. I'll go back to login. Here we'll retain the account ID. This is just our account alias. Make sure if you don't have an alias, you enter the correct account ID. Our username will be KS tutorial, and then the password will be the password we obtained from the CSV file that we just downloaded. Once you enter the details from the CSV file, the username and the password, when you click on sign in, it will take you to a password reset screen like here. So enter the password from the CSV file we downloaded here, and then for the new password, you enter the password you want the user to sign in with now after resetting their old password. Once you've entered everything correctly, you should click on confirm, and the console will let you in, and will successfully access the resources you're permitted to access using this user. Now that we've set up our account and we've logged in as the new user, we need to proceed to the next step where we configure our DNS by creating a Route 53 Hostedzone that we'll use for this tutorial. Make sure you log in into your DNS provider. For our case, we've logged in into our DNS provider here, you can see. And then on your AWS account, navigate to Route 53. And then you can hover over this option and click on Hostedzones, or you can just click on the Route 53 option to open the console. On the left, you can click on this to show the options, and then click on Hostedzones. Here we need to create a hosted zone. So you can use either button. And here our hosted zone will be named tutorials.bloomlessons.com. Make sure this domain is spelled correctly, and then copy the subdomain part. We'll use it later. You can explain what's the purpose of this. And then it has to be a public hosted zone. So make sure this option is selected, and then you can add your resource tags here. Then create the hosted zone, and from here you'll see two types of records, the SOA and the NS records. So we need to add the name server records to our root domain so that this subdomain can be managed by AWS Route 53. So go to your DNS management console, and then under your domain you're going to create the NS records. This is the name we'll use. So make sure you copy it correctly and make sure the spelling is correct. Once you enter the name, it will show you the full qualified domain. Then add the first name server, which is this one. So we copy that, we add it. So you can add the first one. Repeat the process for the second one. So once you've added all the 4 records, give it a little bit, then it will pick. The next step is to confirm that the Route 53 Hostedzone has reflected. The authority section of this DNS record should point to AWS Route 53 instead of the DNS provider. We can do a quick check by using a tool called dig. So you can just run dig, then the subdomain. Under the authority section, it should show you the NS. This was the first one we added, and then this is the host master for Route 53. Once it shows this, it means our Hostedzone is ready to receive new records. So we finished the first 2 infrastructure steps, which are very important. We've created our user, and then we've configured our DNS. The next step will be to set up and configure Terraform on our localhost, and also go over the infrastructure code setup and components. Before you can configure Terraform, you need to make sure you've generated your access key and secret key pairs, and also you need to ensure that you've installed AWS CLI on your local machine. If you're using a cloud instance to run this setup, you can do it on that particular instance. To install AWS CLI, you can follow the guide on the AWS documentation, and then you can install the CLI on your respective operating system. If you're using Linux, macOS, or Windows, you can follow the guide here on this page. Once you install the CLI, you can now proceed to the next step. Go back to the console with the logged in user, the K8s tutorials user, the one we just created. Then navigate back to the IAM console. Then navigate to users, and then click on the K8s tutorials user to open the user page. At the top here, you can see you have an option to create an access key if you haven't created any. You can do the same from the security credentials tab right here. When you scroll downwards, you can see there is a section with access keys. So click on create access key, select command line interface, click on confirmation. Make sure you read this disclaimer. If it applies to a use case, you can proceed and use this by following the documentation. Click on next. For the description, you can just say something like that, as long as it makes sense to you. Then you can create the access key. I can see this user didn't have permission to add a description, which is okay, since they can create the key. That's what we want. Since you've added the access key, make sure you copy the secret, save it somewhere. An easier way, instead of copying them and saving them somewhere, will be just to download them as a CSV file, and then you can open the filelet and use them. Click on done, then continue. Now you can see from the summary page you have an access key which was created today. Now it's time to configure our AWS credentials on our local command line. This step will allow you to create a profile and also add those credentials on that profile on your local machine. Once you've installed AWS CLI using the AWS documentation, the next step will be to run AWS configure, and then we need to configure a profile. So we'll just call it Bloom Lessons K8. Like that. I know it's a long name, but you can use your own name. Just make sure you remember the name. Press enter. Enter the access key that we copied from the user that we created. Then press enter, and then enter the secret key also. Don't use my keys. These ones will be deleted immediately after this tutorial, so they won't be working. So for the default region for our case, we are using US West 2. You can enter a region that's closer to you. or a region that you prefer. And for the output, you can enter JSON, then press enter. Once you've configured a profile, just take note of this name because we'll need it during the Terraform setup. We are on this section, still setting up our infrastructure. We've now generated our AWS profile with the appropriate credentials. The next step is now to set up our Terraform code. We'll manage our state on S3. So we need to create a bucket for that. We'll also configure our backend to connect to this S3. Then we'll create our components and then apply our code. So we are going to start by setting up our folder where we'll be creating our infrastructure code. This folder can be created in any part of your system where you're comfortable doing it. We'll be using VS Code as our code editor. Before you can get started, we need to create our folder. You have to open your file explorer. For this tutorial, we are doing everything on the desktop on this folder. For your case, you can navigate to any location you want, and then you just create a new folder. So this will be your initial step. Once you create the folder, you need to open this folder within your code editor. So for our case, you are using VS Code. If you are using VS Code, it will give you a similar screen as this one. Just click on this open icon. It will give you a file dialog. Then you can navigate to the location where you created your project folder, and then just click on it and then click on open, and then you can get started with the tutorial by creating the IaC folder here. You can achieve the same by just going to the file menu and then clicking on open folder, then navigating to where you saved your folder and then clicking on the folder and then clicking on open, and that will open for you the project folder. I like using a simple structure. So in any Terraform project, we'll always have a main.tf file, which is usually where you reference everything else. Then you'll need a folder for any modules that you'll create. Modules will help you minimize repeating things. So if let's say you're creating an EC2 instance, you can just define a module for that and then reuse the module across multiple sections within your Terraform files. We'll definitely need an output file where we output the values we need to view after we apply our infrastructure. Then we need the variables where we pass in the values we need to apply to our resources. And then something else we need to configure our backend. And of course, we need to have our providers in place. Create a providers.tf file. Our modules will follow the same structure, except they won't have the backend portion. And then you can even go further and separate your data resources from the rest of the resources. We'll have several modules. The first module will be just create its folder, EC2, that will help us create instances. The second one will be EC2 Instance Connect. And then the third one will be the one for creating our IAM user. And then the fourth one will be a module that will help us create security groups. In each module, we'll have a set of files. Here, you'll always have main.tf. You can define providers. A module will also need an output file where it will be able to pass in the output of the resources it has created. And then it will need a variables file so that we can pass in variables from the parent modules. You might also need a locals file where we'll define local variables that will help us transform the input values into the module. Something we forgot, in the root module, you can also add a locals.tf for local variables. We can copy these files across our modules so that we have the structure in place for each and every one of them, just like that. So each of our module has the structure that is needed, and then also our parent module has the structure that we need. The next step is to configure our Terraform setup to be able to save state properly. So open the backend.tf file. And to define the backend, you start with the Terraform block, and then you define the type of backend you need. If you've installed a Terraform plugin on your VS Code editor, it will show you the various types we have. What I prefer using is this. You can use whatever option you use to store state. So once we have that, you need to specify the bucket. So you can just input the bucket name, and then we'll go into the console and create our S3 bucket for our Terraform state. After this, for our bucket, we can name it, let's use this, Then we can set encryption to true, and then we can give our state a value, a key that will identify it within the bucket in case it exists with other files in there. So you can use any name you want here, so depending on your preference. Then finally, we need to specify the region in which we created our bucket, which will be, for me, this is the region I'm using. So for your use case, make sure you use your region. So once we've set our backend, the next step is to go into the console and make sure we've created this bucket in the correct region as shown here. Now that we've initialized our backend code, we need to create the S3 bucket on our AWS account. You have to log in with the user we created for this tutorial. For me, I used this name. Then we'll just go to the S3 console by searching S3 on the search bar. And then we can create our bucket. Remember, the name I used was Bloom Lessons K8 IaC state. The region I specified was US West 2. At the top here, make sure you select the correct region and then enter the bucket name. And now you can leave the rest of the options as default. You can add tags if you need any. And then just click on create. Now we have our bucket here. You can confirm the region is the correct one. And the name is the one we used. We can go to the next step. We need to initialize the code for our modules. We'll start with the EC2 instance. We'll need to add a file that we forgot to add. Under data.tf, we need to fetch the AMI that we'll be using. In this tutorial, we'll be using Ubuntu. So you can use this data resource to get the AMI ID. Here, we'll just name our AMI with the operating system name. Then we'll get the most recent, and then we'll add a filter that will enable us to get the correct AMI. You can add multiple filters depending on your need. We'll use name. Then under value, we'll use this regular expression. We'll be using Ubuntu version 22.04. Then we can add a second filter so that we can narrow down to a specific option. So we can select virtualization type as VM. Make sure your spelling is correct for both cases. And then we can specify the owners. Now take note of this ID. This is the canonical ID. I prefer using images from canonical because they're the authors of Ubuntu. Then once we get the AMI data, the next data resource will be fetching our AWS Route 53. Yeah, we can just call it main. And then we'll be using our DNS name that will be coming from a variable named. We'll add the variable later, and then we'll just indicate if it's a private zone or not. So this one is not a private zone, it will be a public one. Now that we have our data resources defined, we'll define our variables because they are used across the multiple files. So we'll have multiple variables as follows. So this variable will be a bool type that will be indicating whether to create an SSH key for this instance or not. And the second variable will be a domain prefix. In case we need to create a record for this instance. The type of this will be a string, and then the description will be. The third variable will be custom domain variable, so it will be the type object. Then it will have two types of keys, a boolean and a string. The object type in Terraform allows you to define a mixed type object. If we were using a map, it will allow us only to define one type of keys. For such complex data types, it's important you assign it a default value. Create will be false, and then for the domain, it can be by default null. Then we'll have the instance type we want to use. This will be the EC2 instance type. We'll use T2 small by default. Then we'll indicate whether we want to create the DNS record for this host. By default, you can set this to false. Then you can indicate whether to attach an elastic IP to this instance. Default will be false. Make sure for the boolean types you use the correct type as indicated here. We'll have another boolean. This one will show whether the instance should be associated with public IP. Then we'll add the project name. We're adding this to use it as a prefix of every resource that we'll be creating. This additional variable will allow you to uniquely identify a module in case you have multiple modules creating the same type of resource. Then we have the Route 53 Hostedzone name. We'll add an additional variable. Each instance requires security groups to control the kind of traffic that comes in and leaves. We'll add security group IDs here, since we'll be creating the security groups outside the module so that we can reuse some of those security groups for repetitive modules. Then each instance will require a subnet ID where it will be placed. This subnet ID will come from the VPC that we'll create later on in the main module. Just describe the subnet here. Then we need tags. It should be a map of strings. You can use a default value of an empty map. We will be enabling SSH access to some of the instances. This will be the path to our SSH key on our local machine. So give it a description. Then we'll need to pass in the user data as a string. Basically, it's a bash script for the given operating system we are launching. We can finally define the root block device that will be used for our instances. It will be an object with 4 keys. It will have delete on termination boolean. It will have volume size, which will be a number. Then it will indicate whether the volume is encrypted or not, which is a boolean, and also the volume type, which can be GP2, GP3, or any other volume type supported on AWS. Then we can pass in the default values. You can set this value to true. The default disk size, you can set it as 32 GB. Then we want to encrypt our volume, and then the volume type we'll use will be GP3. These are variables that we'll use for this module. Let's move on to the locals.tf. So under the locals, we can initialize the local variables as locals, and then we'll construct a few things. So the first local variable we need to define will be the domain name that will be used for this instance. Then we'll be checking a multiple of conditions. Here we are trying to derive a domain name from the supplied variables. So remember we had the custom domain definition, and also the domain name prefix. And also we have this variable that indicates whether we create a DNS record or not for this instance. The domain name will be derived based on this condition. So we'll check if custom domain is not being created, and also if we have a defined domain prefix. When the domain prefix is not null, then it means we'll be creating a subdomain based on the prefix and the hosted zone name. Then else here we'll have the second condition, which is the second possibility. So we can just move it up. So for the second possibility on the else condition, we'll check if the create custom domain is true, and if it's true and the accompanying domain is not null, then under that condition we are going to use that custom domain as the domain name in this module. And then if neither of these conditions are met, we'll just end up with the empty string, which will eventually throw an error when the resource is being created. Now we're done with locals, we'll go to providers. Since we are using AWS, we'll just add the AWS provider this way, and we'll be using the version 5.0. To get the provider, you can check the AWS provider on Terraform. At the time of this tutorial, this was the latest one. This version might have changed by the time you're viewing this. Once you set our provider, the next step is to now set our resources in the main.tf. Start with the first resource. It will be the AWS key pair, and I'll just name it main. Then since this resource is optional, we'll create it based on the variables that we get. We'll check if the create key pair boolean, which is a variable that we pass in, is true, and if the path of the SSH key is not null, then we create our single resource. So the count will be set to 1. Otherwise, if any of this condition is not met, we'll not be creating the key. And for the key name, we'll be deriving it from the project name, which will be valve.name. And then we'll also be adding the module ID. Then for the public key, it will be the SSH key path. This will be the public key path. And then for the tags, we just pass in the variables, the tags. We can even get creative by merging this. So tags is a map. There is the merge method in Terraform that can allow you to map variables together. So we can match the passed in variables, which are a map, and then we can create our own map in here. Then we can just specify the resource name and then just replicate this. The second resource will be the network interface. Since we'll only have one, we'll call it main. For this one, it just needs the subnet ID and then the security groups, which will be passed in as a list. So just confirm we defined that correctly. Should be a list. Enter the correct variable type. So now we have the security groups. We can pass in the tags. The other resource will be the instance itself. Since it will only be one instance in this module, we can use the main. For the instance, we need the AMI. Remember, we defined the AMI in the data.tf. We just need to retrieve that. So you can enter data. You're taking the ID, the AMI ID, because we are fetching this resource. Then we'll pass in the instance type, which will be next variable will be the key name for this instance. But now we have to add a condition for this key. So we'll be checking if the create key was defined. This is the condition. Remember, we are repeating the condition that we used up here. This means that we can move this. When you see you are repeating conditionals in your Terraform code, you can move them to the locals. You can see this condition matches this. We can copy it and move it quickly to the locals. Here we can give it any name you want and then just add the condition there. We need to check if the key pair is true and also if it's not null, if the path is not null. So if this variable will be true, it means we can just pass it here instead of repeating the same, just like that. Then we can move on. If the key pair is not passed in, then we'll just pass null and then this resource will ignore this key. And for the user data, just pass in the variable that we have, the user data string. Then next we have the network interface block. This one will take network interface ID, which will be from the resource we created up here. And then we have to pass in the device index, it can be set to 0. So that it's our main network interface device. And we'll define our root block device. So remember, we defined the root device down here. So make sure you copy that name and use the same name here. And then we can have the other parts. Then pass in the volume size, which will be, we are using the same variable and the same name, volume size. Will indicate whether our volume is encrypted. For some organization, encryption is must, so can indicate that. Lastly, we'll indicate the volume type. Since this data resource is read every time we run our setup, we need to ignore the changes that it brings so that our instance is not destroyed and recreated every time we run our Terraform setup. Can ignore those changes by passing in this so that this key will be ignored if it keeps on changing. If we want to really change it to a different AMI ID, we can comment this out and do that later on. And then we can just add our tags here. So we can merge our local tags with the ones that came from the variables. So our local tag here will be, can just give this instance a name. We can use the project name, and then we can just add the module ID. Then make sure you correct this one. It shouldn't be a colon, it should be an equal sign, this because it's a map. Then the next resource will be the elastic IP, which will be a conditional resource. This one will be created based on a single variable. So we'll just have this then we check if it's true, we create one resource, else we do not create a resource. That's what this count function enables you to do. So you can combine this with conditionals to determine the number of resources that you are creating. And then we are specifying the instance here, which will be the instance ID of the instance we want to attach this elastic IP to. Then the domain will be VPC by default. You can pass this in, and then the tags will be the tags that came in from our variables. Lastly, we will also add another optional resource, the error 53 record. This one will be created based on the following condition. Since this condition is not used anywhere else, we can use it directly here. We'll check if an elastic IP is created. We are basically checking for two conditions: whether the module has elastic IP enabled, and if the DNS host should be enabled. These two will come from the variable input. So if that's the case, we pass in 1, else 0. So the zone ID will come from this data resource here. And then we need the record name. The record name will be the DNS name we want to create. So remember, we created the domain name in the locals. That's the one we'll use. Then lastly, we need the type. For this case, since we are creating it based on the elastic IP here, we'll use an A record. This type can also be passed in as a variable in future, so that you don't have to always use an A record if you're using a different resource type. Then TTL will be set to 300, which is the default. And then for the records, this is the value itself. We'll just pass in the elastic IP. So remember, for these mapped instances, you have to use indexing because they'll be returned as an array. So any conditional instance like this one, you have to access it with an index like this. Speaking of the same, under key name, we need also to do the same because it's also a resource that is created with count. So that's it on the EC2 module. So let's output the most important details from our EC2 modules that we'll require later on. First output will be the host name, whose value will be based on this condition. Now, since we've used this condition more than once within this module, it's advisable you move it into the locals so that you refactor your code. So we'll just move this into the locals here. And then we'll just say create. We paste in the condition without the ternary question. Then copy the name into the outputs. Just use local.create DNS records. Just retrieve this. Here, that will be our host name, and then ensure you take this condition also back here so that we don't have repeated logic. And the second one, we'll need to know the private IP of the instance. So here the value will be AWS instance main the private IP. The third one will be to know the public IP, if there is any, whose value will be AWS instance public IP. And then lastly, we'll need to know the elastic IP of the instance. If we've assigned an elastic IP, it will match the public IP, but we just want to make sure we have this format. We'll check. So we'll check whether we specified to create an elastic IP. If it's true, then we read this resource because it means this resource will be existing. If not, we return an empty string. And that marks the end of the EC2 module. You can see what we did. We retrieved the AMI, we retrieved the Hostedzone details. Then we created some local variables here to enable us reduce the repetition in the main.tf. Then under the main.tf file, we created multiple resources. We started with the key pair, the network interface for the instance, and then the instance itself, which took in various configuration, including the network interface and the root block. Then for the last two resources, these ones are optional depending on the configuration we pass in under our variables. So we are done with the EC2 instance. The next thing will be to configure the Instance Connect, which will be straightforward. So the Instance Connect won't have any local variables. It will only have an output, a main TF, and the variable section, and also the provider section. So for the provider, we can use the same provider as the one we used in the EC2, since both of them are using the AWS provider. Then under main.tf, we'll define our first resource as AWS EC2 Instance Connect Endpoint, and we can just call it main because there is none other. This one requires a subnet where it will reside, and then whether it should preserve client IP. So we'll pass that variable in later, and then it will require security groups. This will be a list of security groups that will be attached to this connection endpoint that will define the access it can have. So for the tags, we can just pass in the default tags that come with the variables. Then we'll need to create these 4 variables in our variables.tf file. So we can close other files and then just open these variables for EC2 Instance Connect. So here we'll need a string for the subnet ID. Then we'll give it a quick description. Second, we need a Boolean value for this variable name right here. So give it a description, whether the clients connecting on this endpoint will have their IPs preserved. Then second last variable will be security group IDs, which will be a list of strings. And then lastly, we'll have tags, which will be a map, and by default it will be an empty map. Then we can just call this resource tags. Then the EC2 Instance Connect has to output the ARN and the ID, which I will use later. So we'll open the outputs file. We'll just define the 2. For the outputs, I'm using the simplest approach. We'll need the ID here. Value, we'll just take the resource, then pass out the ID. Then that will be it for the Instance Connect. Then for the IAM user, we'll be creating 3 resources. Let's move to the IAM user. We open the main.tf. So the first resource we'll be creating will be the user, and then I'll just call it main. So this one needs a name, and the name we'll be using will be derived from the project name and the username. We can add a Terraform function to use uppercase. Remember, there is a policy that will require this name. The second resource we'll be creating will be the AWS IAM access key for this user. Then we'll just pass in the username, which will be AWS main. So remember, the username has to be always unique, and then this resource will depend on the user resource. Finally, we'll do the final resource, which will be the user policy that will give this user the permissions they require to perform their actions. Then for policy, we just need the policy name, which also has to be unique in this particular context. So here we'll be using the project name concatenated with the IAM username. Then for the user, we'll pass in the user. For the policy, this will be passed in as a string from the variable so that it can be defined from the root module. And then this one will depend on the access key. So once we are done with this, we need to create our variables for this module. For the name, this will be the project name. Then this will be the IAM username. Then lastly, we'll have the IAM policy string, which will be the valid JSON string policy for the user. So for the IAM user, we need to output a few things. We need the access key, and also we'll need the secret, which can all be obtained by accessing the AWS access key.id. The same for here, we'll access the secret from that resource. And that's it for the IAM user. Then lastly, we need to create the security group module. We won't have any locals variables set. We'll jump directly into main, and then we'll define outputs and variables. Before we go into main, let's just make sure we define the provider values for the 2 modules. So we can copy the provider from here, which is the same for IAM, paste it there. and also for the security group, make sure you paste in the provider. Now we have the provider set, we can jump into the main.tf. So for the security group, we are defining only one resource. This is one way of doing it. There are other better ways out there where you can define each component of the security group and then attach it to the particular security group resource. For the name, we are also relying on the project name to generate the name for this resource. Then it will have a unique ID. Then the second thing, you have to pass in the VPC ID. Finally, we need to define the ingress rules. So here we'll use the dynamic block from Terraform, and then we'll have ingress. We can use the dynamic block to produce that array of objects that will be passed in from the variables input. So for the block, it expects for each loop that will be operating on a set of ingress rule objects. Basically, it will be looping through a list of these objects. And then once you define the dynamic block, you can have the content block like this, and then you can define your object in the content block. You can start with CIDR block. Since we are using for each, we'll use the dynamic value. Then you can do .value .CIDR blocks. You can repeat the same for the other values. We'll repeat the same block for the egress rules, and then we'll just make sure we use the correct variable here. So we'll replace for each one of these so that they can read their own dynamic block. Once you set these values, we need to define the variables that will pass them in. Open your variables.tf, and then we'll basically start with var name. So this will be the project name. Can have VPC ID. So our security group has to be created in a VPC. And then we have unique ID, resource. Second last, we need to define the ingress rules and the egress rules. And also we might need to add tags. We'll merge them. We'll have the name tag here, which will use this name that we defined up here. And then we'll be merging this one with var.tags. Make sure this is a map. It has to be wrapped in curly braces to make it a map that way. So we can have var tags, should be an empty object. Then lastly, we'll have two variables defined, which will be of type object. The type of object will have all these fields, so you can just copy these fields because we've already typed them, and then paste the fields here, and then we can modify them quickly. For the values here, it can be a list of strings. This one can be a string. This one can be a number, and this one can be a number too. So it'll be a list of string, still a list of string. For the protocol, it will be a string. For the security groups, it will be a list of string. Then for self, it will be a boolean. So these are the ingress rules, and it will be a list so that we can iterate through it using the dynamic block. We can copy this block because it will be exactly the same for the outgoing rules. So we'll have egress rules. Make sure you use the correct names, and then here you can just change it to egress. Then we are done defining our modules. The next part will be to define the main setup. Let's quickly review what we've done so far. We started by defining the overall structure of our Terraform modules. This is just the basic structure that you should be using for your modules and also for your main directory. It helps you break down things into manageable chunks. Then we created the EC2 module, which had the data section, the locals, the main, where we create the instance itself. Then we output the data. We created this providers file for this module and also the variables file. Then we have the Instance Connect module, which is a simple module. That's why it did not use some files like locals. Here we only have one resource. It's using the AWS provider. It has some outputs here and it has the variables. Then third, we created the IAM user, which is also a simple module. It doesn't have a lot of content in it or a lot of resources. So it just creates the user, generates the access key, and attaches a user policy to our user. Then we have these outputs from this module, the provider, and then we have the variables. Then we have the security group that did not have any locals because it's also just a single resource. So we have the security group here that has these values where we saw good use case of the dynamic block. So for the output, I think we forgot something for this. We need to output the security group ID and also the name. Then if we move to the main module, we haven't added anything apart from the backend. Here in the main module, we need also to add our provider, which we can just copy from the previous modules. If you have Node.js installed, that's even better. I want us to generate a Terraform gitignore file. So to do that, you can just run npx gitignore, then add Terraform. And then with that, it will generate this gitignore file. If you don't have Node.js installed in your system, you won't be able to run this command, but you can try to add this gitignore entries in your project. Start with this one, then tf state files, crash logs, tf-vars, then override.tf, and then finally this section. Remember, I started the tutorial by setting up our backend. The next step will be to set up our main module resources, and then also set up our data resources. If possible, some locals that will help us combine variables, and then we'll also be setting up variables for this tutorial. So let's start with variables. We'll have multiple sections. Let's just create them. We'll have the shared variable section. Then we'll have the IAM user section. I like splitting my variables this way so that they can be identified easily. Then we'll have the VPC variables. And finally, we'll have the DNS variables. In addition, we'll have 3 more sets of variables, so we can just do this quickly. So we'll have Kubernetes variables, and then Nginx load balancer variables. We'll also have Bastion Host variables. For the shared variables, we'll have the following: shared project name. Next, we'll have the AWS region. So for the shared project name, by default, we'll name our project. And then for the region, default region that I've chosen for this tutorial will be US West 2. Then lastly, we'll be using an AWS profile. Remember, we created a profile during the start of this tutorial. The name of the profile variable will be AWS configured provider. So the name of the profile we created while we were setting up our AWS CLI. Make sure if you use the different profile name to configure the AWS CLI with our user credentials, make sure you use that profile name here. If you did not use any profile name, you can just use default. So we've set up our shared variables. The next step will be IAM user variables. For this one, we'll just configure the username. We'll call it Route 53 IAM user. Make sure you add the descriptions. It will be helpful later on. We'll give our user descriptive name so that we can easily identify them. Then the next variables will be for our VPC. So for this tutorial, we'll be creating our own VPC. We won't be using the default VPC. But in your case, once you go through the tutorial, you can decide to use the default VPC and then create subnets within that VPC. So the first thing for our VPC, we have to define its CIDR. So it will be of type string. And then the default value we'll use for our CIDR, it will be, you can use any IP address as long as you know how to map them. We'll be using 12.16.0.0. Then we'll be using this type of CIDR. Then we'll be having private and public subnets. We need to define the CIDRs for those subnets. We'll start with the private subnet, which will be a list of strings. For this tutorial, we'll be allocating 2 subnets. The first one will be 12.16.0.0. This is the initial one. Then the one that follows this one will use 12. So with those 2 subnets, we are good to go. Then for the other part, we need to create our public subnets, which will use the same structure. So just copy that. So we'll be naming this VPC public subnets. From 16, we can go to 32.0. Then from 32, we can go to 48. We can start with the public subnets and then followed by the private subnets. But for this, we are going with this order. Then for the DNS variables, we'll start with the Hostedzone. The name of this variable will be Route 53 Hostedzone name. Type will be string, and then the default value that you are going to use will be the subdomain we created. So if you've forgotten the subdomain, you can go back to the Route 53 console and check it from there. The name of our Route 53 hosted zone that we created was this one. Use the name that you created on your end. The second variable will also be a string, and this one will name it load balancer domain prefix. This will be the subdomain for the Nginx load balancer on which we can access our apps. Then the default value will be set as BareMetal. This one is the one that is supposed to be correct to match the hosted zone. For the subdomain, you can use any value. We also need a domain for our Bastion Host. We'll have Bastion Host domain prefix. Default, we'll use Bastion. You can use any name you want. Then you also need a TLS email that will be used for notifications from Let's Encrypt. This email address has to be a valid address. So for this tutorial, we'll be using the one for Bloom Lessons. You can use a Gmail account if you don't have a custom email address. So that's it for the DNS. For the K8 variables, we need to specify 3 variables. We need to start with the number of K8 master nodes. It will be of type number. By default, we'll have 1 master node. Then so we'll have 2 worker nodes. You can use any number of worker nodes, but it's recommended if you have more worker nodes, you need also to have additional master nodes. So the recommended number of master node is an odd number so that a leader can be selected among them easily. So since we are using 2 worker nodes, we'll have 1 master node. You can go with 1 master node and 3 worker nodes. You can even go with 3 master nodes and 6 worker nodes, depending on your specific needs. The next variable will be the instance type for our Kubernetes clusters. So this one will be a string. If you are doing this for production, make sure you read the Kubernetes documentation for the recommended minimum RAM, minimum disk, and minimum CPU. So for this tutorial, we'll be using smaller nodes to save on costs. Then this will be a map so that we can take 2 values. Then our map will have a default value of master nodes, and we'll have worker nodes. So for worker nodes, we'll use T2 small, or we can just use T2 small for both of them. Then let's go to the Nginx variables. So here we'll have 1 variable, just the instance type of the Nginx load balancer. This one will be of type string. We can just use T2 micro because this instance won't be doing a lot of tasks. If we are doing a production level deployment, we'll have to use a larger instance that can handle the network we expect. So each of these instances has its network bandwidth limit, so you have to check the instance bandwidth, and given the type of network load that will be hitting your instance, you need to use an appropriate size. Then lastly, we need the Bastion instance type as our last variable for the main module. And then the default will use T2 micro. The same for the Bastion host, depending on your use case. If you have multiple users that will be accessing the instance, you can use a larger instance. So we are done with our variables. Let's just review what we've created. Created shared variables, the name, the region, and then the profile we set up with the AWS CLI. We gave our Route 53 user a name that will be used together with the project name to identify the user. And then we defined our VPC with 2 subnets. Then we did the DNS variables for the hosted zone, the prefix for the load balancer, the Bastion host prefix, and also the TLS notification email. Then we defined our Kubernetes nodes This is just the number of nodes and also the instance types and also the load balancer instance type, and finally the Bastion Host instance type. So let's move into the main. So we can start with the VPC resources. I like separating the resources into blocks with comments. So for the VPC resources, we'll be using the AWS VPC module. The name of the module, we'll call it VPC. You can call it any name you like. Then the source will be coming from here. This one can be found from Terraform documentation. For the version, we'll be using version 5.1.2. Then for the name, we can create a name here. We'll start with the project name, which is the one we created in the variables. And then we can just add a string there to identify the VPC. The CIDR variable that we defined. Then you need to define the availability zones. For this one, we'll be defining a data resource. So let's go to the data. It will be called AWS availability zones, and then you can call it main. You can just set a state here and then use the available state. Then that's the data resource we'll use here to pass in a set or a list of the availability zones that we want to use. For this tutorial, we'll be using 2 availability zones. So we'll get the first one, and then we can get the second one. So we'll be using 2. Depending on your use case, you can add 3. Depending on the region, if it can support more than 3 or more than 2 or more than 4, just check on the AWS documentation. Then I will be adding the private subnets from our variables. Then we'll be adding public subnets. We'll be enabling the NAT gateway, and then we'll be using a single NAT gateway. For production, you can use multiple gateways. Then we can just enable DNS host names. Can also enable DNS support and DHCP options on our VPC. Finally, we can pass our tags to the VPC. So we can just merge local.tags. We are merging it with So let's open our locals file, and then we need to initialize the local variables. So for the tags, you can pass in the following names. So this will be the common tags that will be shared across resources. You can just pass project, which will be our project name, var.name. We can just add another tag to show if the resources was created by Terraform, and this one will always be true. And then here we can use the variable as shown here. So we are done with the VPC. The next resource to create will be the security groups that we'll be using. For the security groups, we can add their comment block here. So before we start with the security groups, we can go to the local TF file, and there we can initialize the security group ingress rules. So we can start with the Bastion Host. So this one will be an array of objects, and then we'll just have CIDR blocks, which will be accepting traffic from everywhere. This one can be limited depending on your network requirements. The second one will be description of this rule. This will be for SSH, and then we'll add the from port, which will be 22. Then we'll define this, which will be null. We'll also have the prefix. So instead of an empty array, you can just set it to null. And then for the protocol, we'll be using TCP. Then for security groups, you can pass null. And then the 2 ports, this will be also 22. If the rule is self, we're not setting that, so we'll put it to null. So that's our first rule. Let's use the first rule to create the second rule. So just copy that, add a comma. So for the second rule, we don't have CIDR block. This will be the instance. This will be the Instance Connect security group. Don't have a from port, and it will be using all protocols. So -1. Under protocol, you set -1, and then the 2 port will also be 0. And then for the security group, we have to pass in an array of security groups IDs. So we'll pass in the reference to the EC2 connector security group.id. Then we can define the egress rule. So for this, I can have a shared egress rule. It will use the same block like this one. So here we'll have shared If you want to limit the outgoing traffic in your VPC or in your resources, you can define individual egress rules. But for this setup, we'll be having a shared egress rule that will allow traffic to everywhere. Then for the description, you can call it egress rule. You can add your own description. And then we are allowing all ports. So from port will be 0, to port will be 0. And then for the protocol, it will be any. And then for the rest, it will be null. The next one will be the instance connect. For the ingress rules, we can have the following. For the CIDR block, we are using the VPC CIDR. For the description, then from port will be 0, protocol to any. So you set it as 1. Then to port, make sure it's 0. For self, it has to be true. We can create the next one. For the next one, we are defining the security group for the master nodes. So we'll start with the SSH connection from the Bastion host. Here we need to allow traffic from the VPC public subnets. It will be an SSH connection. Can give a description like this: Bastion access SSH. It will be from port 22 to port 22, and it will be using TCP. For self, make sure it's null. Then for the second block, we're basically allowing traffic for Kubernetes API server. A quick correction: for the public subnets, because they're already in a list, you do not need to put them in a list. For the second rule, it's for the Kubernetes API. This one will allow access from the public subnet and also the private subnet, so that you can access the cluster also from the Bastion host, which will be in the public subnet. You can limit this depending on your needs. You can limit the access to this Kubernetes API from only the private subnets, so that you have to log in into the master node to access it, or you can allow the public subnets, and then you can configure the Bastion host to be able to access the Kubernetes API. So the port here will be 6443, and then the to port will be the same. The third rule will be the etcd server, which will be 2379. So that's the port we are substituting for from and to port. It will be TCP. These ports are also documented on Kubernetes documentation, so you can just jump in there and check. After the etcd server client IP, we need to enable kubelet API, which is 10 to 50. So make sure you enable that port, 10 to 50 TCP. The next port will be the Kubernetes scheduler or kube scheduler. It will be on port 10 to 59. So make sure you replace the two ports. So the next one after the kube scheduler, we'll have the kube control manager, which will be exposed on port 10 to 57. So I just change this to 57. Then if you're planning to use Ingress controller, you can just add this port. I added it here for reference. For Ingress admission controller, you'll need 3 ports, but we are not covering that in this tutorial. So this will be the first one, and then you'll need also the 2 additional ports, the 443 and finally the port 80. We need to allow connection from our Instance Connect security group, so we'll have it here. So from port will be 0, to port will be 0. So for the security group, it has to be a list. That's why you're using the square brackets. For the other rule, we'll add it later after we've created our resources. For the Instance Connect security group, it will not have the CIDR blocks. Fix that. Then for the Ingress admission controller, this will be only from the private subnets, so we do not need to concatenate. The same to this one, and the same to this one. For Kube Control Manager, it will be also from the private subnets. Kube Scheduler will use the same, and then Kube API will also be using the private subnets. For etcd, it will also be on the private subnets. For API, we need it on public because we might need to access the cluster from the Bastion host without accessing the master node. A correction on the etcd client API, it should be 2379 to 2380. So there we go. That's for the master nodes. Let's set the ingress rules for the worker nodes. So for the worker nodes, we'll start with the first block. We need to allow Bastion access. So we'll just copy the one we created for master nodes and put it here. We'll have the Kube API access. So we can copy it from the master nodes also. That will be port 10 to 50 from the private subnets. This one. We'll have node port services on the worker nodes. They have to be accessed from both the public and the private subnets. So we'll concatenate that. The node port services, they'll be running from port 30,000 to port 32,767. This is the default range. So we'll open port 30,000 to 32,767. Then it will be TCP. Then we'll repeat the ingress control and mappings. These ones were for reference. So let's just comment them out. We can enable them later on if needed. Finally, we have to allow our instance connect. We'll copy the previous instance connect configuration. So this one, it will be the same for the worker node so that the instance connect can reach the nodes. Then last but not least, we need to set up our. So this one has to allow incoming traffic on port 80 and 443 from the public, and also it has to allow connection from the Bastion Host and the instance connect. To achieve that, we can just copy these two. So it will allow traffic on 443 for HTTPS. So this will just say HTTPS and this will be HTTP. Since we are allowing public traffic, we'll be using the access from everywhere, the CIDR block. It has to be a string. Same here, it has to be a string like that. Next, we'll be allowing connection from the instance connect. So we can just copy that from the previous blocks since we've already typed it. And then lastly, we'll be allowing SSH access from the public subnets so that we can access the instance via the Bastion host. So we'll just be copying this one from the worker nodes and then adding it here. So we're done with the ingress rules. So we can just collapse this. Then back to our resources, we can create our first resource, the instance connect security group, since it's required by the other resources. Here we can start with the ingress roles, which will be from local ingress roles, then instance connect. Then we'll have egress roles. We'll be using the shared egress role. Then we need to pass in the project name, and we need to pass in a unique ID. Then another required resource will be VPC ID from the VPC module. Then finally we have optional tags. Since we've defined our own tags, we can pass them in like that. The second security group will be for the Bastion host. We'll just name it Bastion. Then for the ingress rules, we'll select the correct ingress rules. The ones for the Bastion node. For the ID, we can name it Bastion. And then for the name, we use the project name. So pass in the VPC ID and the tags. Then these security groups will depend on the VPC module. And the Bastion host will depend on the EC2 Instance Connect security group. And let's go on. Can remove this because already this security group depends on VPC. Third security group will be for our master nodes. The source will remain the same. Then for the ingress rules, we'll have to use the correct ones, the ones for master nodes. We'll leave the ingress as shared, project name the same. Here we just use a specific name, master nodes, and then for the ID will remain the same, the tags, and then this one will also depend on the EC2 connector SG. The third one will be for the worker nodes. And this one, we'll just change the name here, worker nodes, and also change the ingress rules to point to worker nodes. The rest of these remain the same. Then we have to define the Nginx load balancer security group. So this one we'll just name it Nginx LBSG. Then we'll pass in the correct ingress rules. We'll use this one defined for Nginx. Then for the name, we'll give it the Nginx LB. We are done for the security groups. Now let's review the rules and make sure everything is okay. So for the security groups, you'll notice that we are just reusing the same module, which saves us a lot of typing and also a lot of time. So the most important thing here is to review the ingress and the egress rules. We can start with the ingress rules. So the first ingress rule we defined was for Bastion Host. We should allow SSH from all IPs, but this one can be limited depending on your organization access policy. Then we need also to enable Instance Connect access to it. For the ingress rules for the Instance Connect is basically allowing traffic from the VPC network. Then it will allow all protocols within the VPC. Then we have the master node rules. We have to allow Bastion Host access. Then for the Kube API, we have to allow public and private subnets to allow us to access the cluster from the Bastion Host if needed. Then for the etcd server client, we have 2379 and 2380. Then for the Kubelet API, it will be 10 to 50 as a single port. Then for the kube scheduler, which is correctly set already, it will be 10 to 59. And then for the control manager, kube control manager, it will be 10 to 57, which is already set. And then we added the Instance Connect to allow the Instance Connect to be able to reach this node from the AWS EC2 console. So for master nodes, that's okay. You can collapse it. Then for the worker nodes, here we need to allow SSH from the Bastion Host. That's basically the public subnets. We need also to allow access for Kube API on port 10 to 50. As for the worker nodes, we need to allow access from the public and private subnets for the node port service. So that's from 30,000 to 32,767. Then we need to allow Instance Connect to be able to reach this node. Then for Nginx node, we need HTTPS traffic from everywhere and HTTP traffic from everywhere. But for SSH, we are limiting it to the Bastion Host, and also we are adding the Instance Connect connection. So that's it for the security groups. Now the next resources we are going to create will be for the IAM users. So we'll only have one. Let's just create a block for that. So IAM user. Our IAM user will be created from the IAM module we had initialized. So we'll name our user with this name. If we had multiple modules, we'll use a different naming convention. Then here we can just pass in that. And then for the user, he doesn't need a lot of variables. We are just passing in the username that they'll use. var.route53 use IAM user. That was the username. We need to pass in the project name. And then finally, we need to pass in the policy. So for the policy, it will come from local variables where we can define the policy there. It will be a simple policy that I'll just type. So it will use this name. And then under locals, we'll create that policy below the ingress rules. So this one will use the end of file delimiter. And for this one, at the end, it will end a string block with that. And then in here, we can add our policy. It should be an object. We'll start with version. Then for the statement, this will be an array block with the following object. This string has to be a valid JSON string. If not, you'll get an error. This is quite open, so you can limit by resource here, and also you can limit the permissions at the top here. Now we have our policy. We just make sure it's referenced correctly here, and that will be our last variable. The next section will be for the Bastion Host, which will need user data for setup script. Here we can just initialize the module quickly. For the source will be the EC2, and then we can enter the different options. So before we start on this one, we need to create the instance user data. You can do the user data after the IAM policy. When you're typing this type of string, using the end of file delimiters. You need to make sure that if we have an indentation here like this one, if you press enter, you have to go back to the beginning of the file, and then your string has to start from there, and then the end of file delimiter has to be added at the end so that it makes a valid string. Let's start with the Bastion Host userdata script. We'll start with the first one, which is named the Bastion Host script. It will be a bash script. So here we'll be making sure that the SSH directory exists for the current user for our operating system. The user is Ubuntu, since we are using the Ubuntu OS. If you're using another operating system, you'll have to add the name here. Then we'll have to run this command, create a file using the cat syntax. This will be using this syntax here, and we'll be entering this path that we just created. Then we'll be creating the authorized keys using our public SSH key as an entry. Once you have that, you can use Terraform file function to read our SSH key, which will be created in the following location. Let's add the syntax first. So it will be path.module. The current module, we have to close that, and then we'll have a subfolder named SSH keys, and then the key will be named, so using the public key. Then for a valid Terraform string literal, it has to be in quotes so that it can resolve correctly. Make sure the quotes are in the right location. We can also copy our private key that will be used for accessing the private nodes on our private subnets, so we can use the same approach here. Ensure you close this. So we opened a single quote here, it has to close the statement. Then the same here, it has to be closed. You're copying the private key into the server to use this name as one of the default keys there. We'll also be copying the public pair. Once we have this, we can proceed and install kubectl. So if you'll be accessing the cluster from the Bastion Host, you can install kubectl using this command. So we'll just be pulling it from an S3 bucket and then giving it executable permissions, and then moving it into the executable path of the current user by using these two commands, and then add it into the terminal initialization file bashrc. Once you install kubectl, you can install other prerequisites, like if you'll be running Docker on this instance, you can install Docker. If not, you can skip that and then end our script for the Bastion Host. For this resource, the first variable you're supplying is whether you'll be creating a key pair. So the answer for this will be false, because we are doing that through the user script. Then if you'll be creating an elastic IP, the answer for this will be true. Then if you'll be creating a DNS host, it's true. We need to assign a host so that it can be easily referenced. Then for the SSH key file path, you can just add it here. And it will be SSH keys and Bastion. For the domain prefix, we'll use the variable that we supplied, Bastion Host domain prefix. For the instance type, we are going to use the Bastion Host instance type. And then for the name, this is our project name. And for module ID, we'll just name it Bastion Host. The Route 53 Hostedzone name. Then we have to pass in the security group IDs. So this will be module. Then for subnet ID, we'll be referencing a data resource. So let's go and create the data resource. We need to press our Bastion Host in a given subnet. We can identify that subnet here by using AWS subnet. We can specify it as Bastion subnet. Then for ID, you can just use the module.vpc public subnets. Then we'll take the first one for the Bastion Host. We can take this opportunity to define the next data resource that we'll be using. It will be the one for Nginx LoadBalancer subnet, and then for this one it will use 1. So then when we come back to main, we can reference the data resource, then we can access the ID. Then we need to pass in the common tags, and then pass in the user data string. That will be from local Bastion Host script. For the Bastion Host scripts, just a point of correction. So this is supposed to be keys. And then if you skip this, you have to set this one to true, so that the EC2 instance itself will add that key to the authorized keys. So yeah. That's why we set this to false, because we are doing it manually in the user data script. So we are done with the Bastion Host. We can go to the next resource. The next resource will be the Kubernetes masternodes, and we'll initialize the module. And then we can add the count. So we'll be creating these resources based on the number of masternodes. For the source, it will be the EC2 source submodule. Then if we are creating a key pair, we can set this as false. The main prefix, we can pass it as null. If you pass as null, Terraform will ignore that variable. For instance type, we'll have its instance type. And then we can just say master to reference the master node. And then we can specify if you need to associate public address, so it will be false. The next variable will be a project name, it will be var.name. The module ID will be the same to master. And then we are using count.index and then +1. For the Route 53 Hostedzone name, you can just pass it in. Although it won't be used for this node, you can update that in the module setup and pass in a default of null. For the security group, we'll add module dot, we copy the security group name for master nodes, is here. Then we extract the ID from that security group. For the subnet ID, we'll have to obtain it from local.k8. We have to create this variable. So we can create the following local variables for this. So let's just copy this. This one will give us the IDs. And for master nodes, you can take 0. You can create another variable for worker nodes. You can use 0 or 1. For this tutorial, let's put everything in the same subnet. But in case you have many nodes, or in case the worker nodes will grow past the limit of your IP address block, you can use a different subnet ID here. So that one is specified. And next thing will be the user data, which will be from local dot, we'll just call it master node script. And then for the tags, we'll have the local dot tags. We need to correct something on the EC2 instance module. Under variables, we need to make this variable have a default. For the default, it can be set to null. Okay, so we need to define this. Let's go where we define the other user data script. So below the Bastion Host script, we need to define the master node script. It will use the same format. So the first business under locals for the master node, we'll just be creating the SSH key. So we'll just have to do this, what we did here on the Bastion Host. That's all. Then the same will apply for worker nodes. Can just add worker node script. It will use the same approach. And then let's just create this folder so that we avoid confusion. For the SSH keys folder, it has to be created in the root module. Make sure you create it in the right place and use the correct name, SSH keys, the name that you're using on this path. We'll generate the keys before we run the setup. Now we have the worker node and master node script. Let's go back, and here we can reference the master node script under the master nodes, and then we can just copy the whole block and use it to generate our worker nodes. Then for the worker nodes, we'll just change the name to worker nodes, and then here we'll change it to number of worker nodes. We'll use the same module. We won't be creating a key pair for the instance. Then for the instance type, we'll be using the correct instance type reference, the worker. Then we'll be using the same project name. For the instance ID, just change it from master to worker. The Hostedzone will remain the same. Then here for the subnet ID, just make sure you reference the same subnet ID here. Then here for the script, make sure you reference the worker node script, and then the tags. And we are done with the worker node. Then lastly, we need to set up the Nginx instance before we finish with the Instance Connect. Let's create the Nginx load balancer. So for this one, we'll just initialize it similar to the other modules, and then we'll name it Nginx LB. The source will be similar to the previous modules. Then we won't be creating a key pair. We'll be creating an elastic IP. So this one will be set to true. This one will be false. We'll be creating a DNS host. That's true. For the domain prefix, we'll set it to null, and then we'll supply a custom domain, which will be an object of 2 two variables. So we'll be creating a custom wildcard domain instead of using normal subdomain. So for the domain, it will be star, and then here we are passing in the load balancer prefix. So it will be the one we supplied from our variables. It's actually this one, load balancer domain prefix. You can now append the Route 53 Hostedzone domain. So the difference between supplying a custom domain and supplying a domain prefix, if you supply that prefix, then a complete subdomain will be created. But if you use this variable that we created, it will allow you to override the default behavior, and then you can pass in your wildcard subdomain, which will be appropriate for the use case of Kubernetes, whereby you can map multiple resources using the same wildcard subdomain. And then let's just enter the instance type. Remember, we specified the Nginx load balancer instance type in the variables. Then we'll enter the project name, which will be var.name. Then next we have to specify the module ID, which will be Nginx LB. Then remember, we have to pass in this variable Route 53 Hostedzone. Then you can pass in the security group ID. After the security groups, you need to supply the subnet ID. The next one is user data string. This one will be supplied from the local. Then here it will be the Nginx LB host script. We'll create that in a bit. The next variable will be supplying tags, which will use the local variable for tags. And then lastly, we'll put the dependency. This module will depend on the security group module. So it will be module.nginx lbsg. The same up here will have depends on. Then here we can just add module worker nodes security group. For master nodes, the same. You need to put the dependency to the security group. So we'll just add module.masternodes sg. Then for the dependency for the Bastion Host will be the Bastion Host security group. Once we put our dependencies for those resources, we can go forward and create the Nginx userdata script. Specify it just below the worker node. We'll initialize it the same way we've initialized the others, and then we'll end the initialization. So it will be a bash script like this. So the first step will be to install Nginx. The first step will be to install the dependencies. So first of all, we start with getting the update. This is followed by installing the dependencies. We are installing wget and curl. Then now we add the Nginx repository by running these commands. Next, you are getting the Nginx signing key from this URL, and then you are adding it into the apt keys using sudo apt add yes Nginx signing key. And then lastly, we are installing Nginx by running sudo apt-get update again, and then followed by sudo apt-get install Nginx. And then this one is followed by an option yes. Once you install Nginx, we need to enable it. So we run sudo systemctl enable Nginx to enable the Nginx service, and then we start the Nginx server. The next step will be to set up the SSH key. So for this step, we can just borrow what we did up here. The next step, we need to generate a TLS certificate for encryption. So here we can use the doc syntax. We're still using the bash command to run our string as sudo. We just run the following: sudo s. We'll be using a different delimiter doc. And then within doc, exporting the AWS key and the AWS secret. These ones are being read from the IAM user module. Then once we do that, we are creating the default AWS profile. For certificate renewal, here we'll just make the directory. Once we make the directory, we create the file. So we'll use the same cat syntax. So we are just doing bin bash. We pass in the string as a command. Our string will be cat, followed by end of file delimiter, and this one has to be wrapped in double quotes. It's sending the output into our file, which will reside in the root.aws.credentials. Make sure this file path is correct and also the file name is correctly spelled. Then here we'll end the command with a single quote. And then within the file, we're just basically creating what the AWS CLI creates for you when you are configuring the access keys. Just create this for our AWS access key and also the secret key. Then we need to install socket and cron tab. So because acme.sh relies on this, just do apt-get install socket and cron tab. Then we allow them. Then we'll be running the script provided to us by acme.sh. This one will install acme.sh on the server. Once we install acme.sh, our bash file will be updated, so we need to reload it so that it can load the acme.sh path, and then we need to run the following steps one by one. Acme.sh upgrade, auto upgrade. This one upgrades the client, make sure it's latest. Then we have acme.sh set default CA server let's encrypt. This sets let's encrypt as our default CA, and then we register an account using our email, so the email that we passed in the variables, if you remember that. Then lastly, we issue our certificate. Then we'll be passing in the Nginx load balancer domain name. So for that one, we have to create it in the locals. So let's head there and do it right now. When you go back to the Nginx module, you'll notice that we are passing in a custom domain name, this one, which we are appending a wildcard in front of. So now to generate the certificate, we can just take this variable the way it is, and then under the locals, we can create the new variable at the top here. So it's called Nginx LB domain name. Instead of using the star, we'll just add the domain without the wildcard. Now we'll copy this, and then if we go back to our Nginx script, we can use the local.nginx domain name. This will be the first domain, and then the second domain will be our wildcard domain. So this one will be recreated like this, and then we just repeat the same value as supplied here. And the next step is to configure Nginx with our TLS certificate. If any of the mentioned steps do not work from the generation of TLS certificate up to the last step, the setup might not work and you might need to do some manual updates in the Nginx server. So let's configure Nginx with the TLS certificate. We'll be getting rid of the default Nginx configuration. Then we'll be creating a new file, and then in this new default file, we'll be setting the following: an upstream block, which will be named backend, and then it will have its values will come from local variables. So this will be the private IPs of our instances, worker nodes. And then we'll have the server block. So the first server will be the default server. It will be listening on port 80. And then the server name will be the load balancer name, but using a wildcard so that it can capture all the subdomains that will be created on this wildcard domain. The second server block will listen on port 443 and it will use SSL. The server name will be the same as this one. So for the certificate and the key, we'll be referencing the user that created the certificate. We used sudo to run this command. So this certificate will be generated in the root user home directory that we are entering here, and then it will be in the acme.sh path, and then this will be the default path of the certificate. The domain name without the wildcard, and then followed by _ECC, then full chain.sat. This is the correct path. If it doesn't work, you can always log in back into the node and check where the certificate was generated, and then replace this with the correct path. For the key, the same thing happens. So the domain name forms part of the path, then the domain name.key. Then we need to add two options here: SSL protocols and also client maximum body size if it will be needed. So the reason I included this option here is because if you'll be using your Kubernetes cluster to run your API, and maybe your API has an upload functionality, this size will limit the maximum upload that can be sent to your API. Then finally, we'll add the location block. We'll use the default location so that we capture everything. And then we'll just add two options. We'll add the reference to our upstream and also the proxy set header option. So this one will preserve the host where the request is coming from. And then this one will reference our upstream. our upstream will point into the worker nodes on the given node ports. After we create our cluster and after we install our Ingress controller, we'll come back to the Nginx server and then set up the correct port, but the IPs will remain the same. So once you're done, we can end the Nginx configuration script here. So it started here with a single quote and then it is ending here with another single quote. So the next thing will be to continue the configuration. So you can debug the file here. You can just do a test and then restart and check the status. So let's go and configure this local variable at the top here. We'll have a local variable with a name local Nginx upstreams. So let's assume it's an array. So this is the logic that we'll use to generate that variable. So we'll start with the node port. Let's just move this down so that we create separation between the two variables. Before the upstream, we'll need the node port. So this value will be changed later, depending on the one that we'll use for Ingress. And the second value will be worker nodes private IP. For that, we'll have to access the module.workernodes. And since it's an array of several items, we'll just do in the EC2 instance module, we are outputting the private IP. So that means we can access it this way. And since the worker nodes are created by account directive and Terraform, we can access it as an array and then use a wildcard to access everything, which will give us a list or a set. Then we need to create another variable. In this other variable, we are converting the results from here into a JSON encoded string. So here we are looping for each of the private IPs. So you can see this is the variable that contains the private IPs. So let's just use a descriptive name here. So we are looping into each one of these, and then for each one of them we are creating a new string. So this string will be server, and then for the server we are passing in the IP, and then we are attaching the port at the end. Then once we do this, we need to finalize the object by making sure that we are creating a valid object for Nginx. This sort of a manual process, but you can come up with a better approach. For this one, we are just doing a string replacement. First of all, we'll be removing the square brackets from the list, and then we are removing the closing square bracket, and then we'll be removing the double quotation. Once we remove the double quotation, we finalize by removing the extra commas so that it forms a valid Nginx configuration. So once we have this, we can just confirm it's the same variable that has been referenced here. Then lastly, after we create our VPC, we need to create our Instance Connect. Let's add the resource block comment, and then we can just initialize the module. We'll name it EC2 Instance Connect. Then the source of the module will be modules EC2 Instance Connect. Then to the module we are passing the name, project name. For the module ID we are passing in EC2 Instance Connect, and then we are preserving the client IP, setting the security group. Then you have to pass in the subnet ID. For this one, we have to create it on the local variables. It will be local.ec2 subnet ID. We'll go back to the locals quickly, where we define the subnets. We can add the third one for Instance Connect, and we'll have module.vpc.public subnets, and then we select the second one. And here we have that. And finally, we will supply the VPC ID, which is required. We can pass in the tags. So we do not need name. So let's go into the module and see if we can fix a few things. Yeah, so we do not need the VPC ID, and also we do not need the name. So we can remove these two. We also don't need this. So we just need those three, and we are done with the Instance Connect. The Instance Connect will be depending on its security group. Then we can move this resource lower after the security groups because it depends on the security group. So we'll put it just above the IAM user so that we have some sort of order. I think we've created all the modules. It's time now to generate our SSH keys. So for that, make sure you've created this new folder in the root module in the IaC folder. So create the SSH_keys, then right click on it and open it on the terminal. You can use your terminal and navigate to that folder. That's another option. Then here we need to generate valid SSH keys. We'll be creating an ED25519 SSH key, and also our key has to be in PEM format. So to generate the key, we'll be running the following command. Then the size of the key can be adjusted. You can use 4096, So for the path, copy the path of this folder. Just copy the whole path, then we paste it here. And then at the end, we need to add this file name like that. So make sure you copy the whole path of this folder where we created the subfolder SSH Keys like this. And then at the end, you append the key file name, this one. Then we press enter. So we won't be using a paraphrase for this key to keep it simple, but for production environment, you need to put a paraphrase to add additional security. Then once you do that, when you check the folder, you'll see the 2 keys. So now we've generated the SSH keys. The next thing will be to run our setup and also validate that everything is working as expected. So let's continue. When you go to your locals.tf, there is some mistake we made during the Nginx setup step. So when you go to the Nginx script, you realize that initially we had typed the apt install without accepting the installation. So this will require an interactive session, but this script will be running in the background, so we need to auto accept the installation. So make sure every apt-get install command has a yes option added to it. Now let's open our folder in the command prompt. So make sure you navigate to the IaC folder where we have the Terraform file set up. Then we need to initialize our backend, but before we do that, on your local machine, make sure you are using the correct AWS profile. So you have 2 options. You can add a profile directly into the backend here so that Terraform can know which AWS profile to use on your local. So let me just check my profile name the way it was called. So this is the profile we are using. So you can add it directly to the backend and you won't have to worry about Terraform connecting to a different account or using a different profile. Or if you don't want to use this and you want to be explicit, every time before you run your Terraform command, you can just export AWS profile variable and then set it to that value. So once you specify the AWS profile you're using, the next thing is to initialize the Terraform setup. And then if everything is successful, you'll see this message, successfully configure the backend S3. This means that using the AWS credentials that we set, Terraform is able to access the S3 bucket that we have specified here in this region, and it is able to create the state using this name. So we're getting an error, or it's a timeout operation. And then we're also getting a warning on this file. Let's fix it quickly. Under the EC2 module on line 30, we need to fix something there. Ignore changes should be in literal string. Then now we had a timeout error. I think we are having an issue with our connection. So let's fix it. So let's run Terraform init to initialize our Terraform module. The initialization command will pull in the required plugins, and also it will initialize the specific modules that we are using here. Once everything has been initialized successfully, you should get this message if you set up your credentials properly. And then the next step will be just to validate. So we can run Terraform validate. This one will give us any errors that we might have created. So you can see we have multiple errors. So it's complaining there is no module called module. So we go to main.tf line 92. So this is a debugging session. So we just remove that. Then on line 78, you can see the error here. We can fix that too. We can remove the extra module. And on line 64, we can remove the extra module too. And then on line 50, we can see the same error. So that's the use of Terraform validate. Then now you can see it's complaining about AWS availability zones. So let's go to our data resource and make sure we declare the correct module. Here we have the data.tf. We are using .available. So we should change this name to reference the name that we used here. You can change it to main. Just check if there is any other error. After you do that, you can save everything and then run Terraform validate again. You can see it has found new errors. In the Bastion Host on line 37 main.tf, you can see there is a spelling error. So it's supposed to be VPC, not VCP. You can see it's the same error multiple times because we are using the same module in different places. So that's another error we fixed. So you can run Terraform validate again after saving. And once you fix all the errors, once you run validate again, it will show you valid syntax. And that marks the end of the code setup. In the next steps, we are going to run our infrastructure code, and then create the resources on AWS and debug if we face any issues. Then after that, we'll move on to set up Kubespray and then install our cluster. See you soon. We've now validated our code. You can take some time and review, especially the user data scripts in the local. So the reason why I put the scripts in the local is to allow me to be able to read the variables from resources within Terraform. I prefer this approach because it's more dynamic. So make sure you check the scripts that we wrote. If the script has an error, it will prevent the instance setup to be done correctly. So we start with the Bastion Host. What we are doing is just making sure this directory exists, and then after that we are creating the authorized keys with an S at the end, and then we are putting in the SSH key that we created. The same to the creation of the key itself. So I just lifting the key from our local and putting it into the Bastion Host. The same for the public pair also. Then we are installing kubectl using the AWS recommended bucket URL. This one is from the AWS documentation for installation of kubectl. Then for the master node, we are just adding the SSH ability by creating the authorized keys. For worker nodes, we're doing the same. We're just setting up the SSH access. Then for the load balancer, this is where we are doing a lot of things. So we need to review each step. Just make sure you check each command and make sure it's doing what is required. You can get the Nginx setup instruction from the nginx.org documentation. You can find the installation on the various Linux distributions. Make sure you check everything here. So setting up SSH access is similar to the previous sections, so this one is okay. Verify these commands are not missing anything before you run your Terraform apply. So for cron tab, let's verify if this is the correct package for Ubuntu Linux, because the packages vary for different distributions. I just verified the correct package name here should be cron, not cron tab for Ubuntu. Then here, make sure we are referencing the correct variable for the upstream. And then just make sure every Nginx instruction has a terminating semicolon at the end to make sure the configuration is valid. I think that's it. So while in the same terminal where we ran Terraform validate, within the root folder of the IaC setup, we need to run Terraform apply. So Terraform apply will run the plan. Then it will prompt you whether you want to apply the plan or not. So let's make sure you're using the correct binary Terraform. So let's run Terraform apply for setup. Then you can make the terminal bigger. You can see we are getting an error about the JSON policy as an invalid character V. So let's go to our JSON policy. We know that this policy is passed from our local variables. So you can see the policy is coming from this module IAM-user main.tf line 13. So when you go to main.tf, when you go to the IAM-user module here, you can see where the policy is coming from. We'll just go and check the policy, make sure it's using the correct syntax. And you can see we forgot to quote the first key, which is version. Make sure you apply this correction. So once you do that, we can run Terraform apply again. So some errors like these ones won't be caught by Terraform validate. Some of these errors will be caught when Terraform is trying to plan your resources. So you need to fix them before you can be able to successfully run Terraform apply. If the apply is successful, it will show you the summary of how many resources are being added, how many resources are going to be changed, and how many resources are going to be destroyed. Before you run this Terraform apply, make sure you have exported your AWS profile, or to be safe, make sure you set the correct profile here in the backend.tf file to ensure that these resources do not get created in a wrong account. We'll just proceed with yes to apply the resources. It will take a few minutes, and also we might get some errors that we will debug. So we are getting an error here. We are being told we're trying to create this user, but our current user, the one running this setup, does not have authorization to perform this action on this user. So here, this is the module that creates the user. This module takes in the name, the project name. For this case, our project name is Bloom Lessons 8. So that's what we are passing here as the project name. And then for the username, this is the username we chose. So we decided to call our user route53-user. Now, within this module, if we open the main.tf, when you come to the user, what you are doing, you are taking the variable name for the project that we're passing in, and then we are joining it with the IAM username that we just passed in, and then we are converting the whole string into uppercase letters. Now this is the name of our user. Now you can see the name is the project name plus the substring of the user that we added. Copy this name, this username here, exactly the way it is. And then let's go to the console and fix this, and then come back and apply our changes. Once you log in into the console, just search for IAM, because that's where we want to fix our policy. Then you can go to user groups, because we were using a user group. Then open this user group that we created for our user for KH tutorials. Then here we need to edit the permissions so that we can correct the reference to our IAM user. Under the user group details, click on the permission tab, and then click on the custom policy to open it. It will open on a new tab. Then here is where we are editing, so look for the last right permission. This is the name of the user. This name has a hyphen, this one doesn't have a hyphen, so I think this is the mistake I made while creating this, but it's a good mistake because it will show you now where this name came from. So we set the name correctly here, and then we can save the policy. So you can see also the error we are getting. This user of ours is not authorized to perform IAM put policy because we restricted K8's tutorial user not to have explicit permissions on our AWS account. So the right user to use for updating this policy, the user that we used previously, was the admin user of this account. So if you don't have an admin user, you can create one using the admin access policy, or you can log in with the root user, and then you can do the steps that we did here. So with the admin user or the root user of your account, you can go to IAM console. And then from here, you can go to the user groups. Under the user group, open the target group you are working with, this one. Then go to the permissions tab, click on the custom inline policy. It should open on a new tab like this. Copy the user that we got from Terraform, the username that we created from Terraform. And then within this statement, update the user here. You can paste the name at the side here so that we see the difference. You can see this name has a hyphen, this one doesn't have a hyphen. I forgot to update that. So once you do this, click next, review the policy, then you can save the changes. It will take you back to the permissions tab. Click on the policy to expand it, and then it can show you the JSON format. So you can see now we've attached the correct username, and then with that we can go back and rerun our Terraform setup, because now our K8 tutorial user will have access to managing this user on our console. So we've given our K8 tutorial user permission to manage this user. Now we can rerun our Terraform setup, which should now work or give us another error that we shall debug. We just run the previous command, Terraform apply, which should read the created resources and then pick up from where it failed. So here you can just check what is being created and what is being destroyed. So no resources are being destroyed. This is the critical part to check, and also no resources are being changed. So which means you're just creating new resources. Type yes to confirm. And then you can actually see when you scroll up, our IAM user module is being created this time round. So let's wait. The user has been created. Now we are moving to the other resources that were not created previously. So the reason why the Nginx load balancer was not created is because it relies on the IAM user. It depends on the IAM user. So without the IAM user, Nginx won't have the access keys to run the user data script that we passed to it. I just remembered we forgot to output the data that we'll need from our main module. So let's do that quickly. On the output part, we need to add the output data that we'll use to set up our Kubespray. So to do that, we'll add several output variables. We start with the Bastion Host. So we'll have output. So this will be just the Bastion Host details, and then it will have a value of a map. The map will have the host name. So let's look for the Bastion Host. So this is the module. So make sure you're referencing the correct module name. And then when we check the EC2 module, we can see from the outputs, we are outputting the host name. So we need the host name here, dot host name. We shall repeat the same for the private IP. When you check from the outputs of the EC2 module, we have this name as the one for private IP. You can copy the same and replace that with public IP, and then we can copy that, and then we can output the elastic IP. So the next one will be Nginx load balancer. So for that, we just say Nginx LB. So we have the Bastion host details, so we need the Nginx details. This is the module name for Nginx load balancer. And then just replace it here in place of Bastion Host. Then copy this. Let's do the same for master nodes. Then for master nodes, you just take the module name like this. Because it's created by count, we are adding a selector to select all the instances if in case we have more than one instance in future. This is the syntax of selecting resources created by count. And here we have worker nodes. So just copy this block, paste it here. So for worker nodes, you just check for the module name. Since worker nodes are also created by count, here we can just change the name to worker nodes. So module.workernodes.star.hostname. So each one of these entries will give us a list or a set of values. So we can work with that from the outputs. Now, once we've added our output, which is a step that we forgot, you can rerun the Terraform apply, which will now give us the output. This is what you get. So I want you to copy this output from the bottom, copy it up to where the outputs begin. And then within the Terraform folder, within the IaC folder, create a new file, name it outputs.txt. So when you use a non-tf extension, it won't be read by Terraform. So let's just review the output before we go on. This is the host name of the Bastion host. You can use the public IP or the host name that points to the public IP. So for production setups, using the host name is much appropriate because people remember the host name much easier than they will remember the IP. Then for Nginx load balancer, this is our load balancer host name. So you can access this on any subdomain of this domain, and then it will resolve to this IP. Then for the worker nodes, you can see we only have private IPs because we did not attach public IPs or elastic IPs or host names. Then for the master nodes, the same. We only have a single private IP in a list because we only created one master node. So now we've created our infrastructure. We've set up and configured our Terraform. So the next step will be to set up Kubespray. So you can see here. And we'll start by setting up the inventory and then pulling and running the Docker containers and then debugging our setup to make sure we've installed the cluster correctly. But before we do this, let's quickly review our deployed infrastructure to make sure especially the load balancer was set up correctly. For that, you need to log in into your AWS account using the K8 tutorial user that we created for this tutorial. So once you log in, since we created EC2 instances under VPC and also used Route 53, you can confirm those resources from the specific consoles. So make sure you are in the correct region, the region that you used in your Terraform. For our case, we used US West 2. So let's go to our EC2 console. You can search for EC2. So you can see we have 5 instances running, and then you can even see the number of security groups is 7, and the volumes we are using are 5, which matches the instances. And then the elastic IPs we are using are 3. One is for the VPC, one is for the Bastion host, and one is for the Nginx load balancer. So you can confirm the instances by clicking on instances running or clicking on instances on the left panel. Then here you can see the names. So we have the load balancer, we have the worker nodes, 2 of them, we have the Bastion host, and then we have the master node. Then another thing, remember the host name for our Nginx load balancer was attached as a wildcard domain or subdomain. So let's just make sure we can access it. So here you can see this is the wildcard subdomain that was output by Terraform, the one that we configured. So you can type anything before it, like test. You can type anything before it to just confirm that the Nginx is working. So you can see we can access our Nginx, but something did not work. You should be able to access it with HTTPS. So we need to log into our instance and check the error. We can't use Instance Connect because the user we created does not have access to that. We'll add the access later on once we debug the Nginx issue. So we'll use SSH-I. Remember where we created the keys. So run this SSH command within the IaC folder. And then you can use -I. Then we are using the current directory, SSH Keys, and then we are just entering the private key path. Then the name of our Bastion host was this. We can just say Ubuntu. That's the username, the default username. Add the host name at the end. So you run this command, can approve. we are now inside the Bastion Host, and then within the Bastion Host, if you ls.ssh in the home directory, you can see we have the private key. Now we need the private IP of the Nginx load balancer, this one, not the public IP. Take note of that. So within the Bastion Host, just run ssh, use the input, and then we are in the home directory. So you can use the tilde then .ssh. Here the key was named id, so using the default name. So you do not need to type the I option because it's the default key and it's the one that exists in the SSH folder. Then enter the default username that we use for Ubuntu, and then enter the private IP of the load balancer, which is that one. So you confirm the login, and then we are inside the load balancer here. We can clear the screen and then we can run system. Can just check status Nginx. That's the first step. So Nginx is running. We could access it on the browser on port 80 previously without HTTPS. Now the next step is to check the configuration. So remember, we configure the user data script here in the locals.tf. So go to the Nginx load balancer host, and here you can see we have the installation part. When you go to the part where we are configuring the Nginx with TLS here, this is the file that you'll open. So you can just vi etc nginx conf.d default.conf. So when you open that file with vi, you can see this is the setup we have. You can see there is nothing that was done, which means our user script failed at some point. To debug that, can use journal.ctl. My best guess will be our user script failed before it reached this point, so we can debug upwards. So we can start with the previous command before configuring TLS. So previous command here was the acme.sh. So we can just search for this from journal.ctl, and we can just grab that, and we can see what happened. So these are the previous logs of that command. So it registered and then something happened. I don't know. We can't see any further logs. So this is the time when the script started running. I run journal.ctl since, and then we can start since we started downloading acme.sh. So this is the time. So we'll just put it in a string, and then it should be in UTC format. So it will be 2023 12:05, and then the time, enter the time here, this time 12:27:34. Can try with that. It will show us everything that happened there. And here we can see acme.sh is running. So we are downloading the script. We've installed cron job, and then we are running the acme.sh here now. We've created the account, okay, we've registered, and then so the issue is this parameter. We can see our error, so we need to fix it. Let's go back to our user data script, and here you can see we have DNS_AWS. So I found the issue. So you can see from the logs here, our issue is this unknown parameter. So it should be an argument that is passed to the DNS parameter. Once we fix this, we can just exit our terminal. So press Q and then exit. So when you exit the load balancer, and then it takes you back to the Bastion Host, and then you exit the Bastion Host. You can see the connection to our Bastion Host was closed. This is the private IP of the load balancer, was also closed first. So once we do this, we go back to the console, log in into your console using the K8 tutorial user that we created, and then select the instance from here, and then click on the instance state, and then click on terminate, and then you wait until the instance reaches the terminated state here. So make sure if there is a filter up here, let's say a filter of instance state running, remove the filter, you clear it so that you can view all the instances. So you can see once the load balancer is terminated, we can go to our Terraform code with the updated script and rerun the Terraform script to recreate a new instance for us. This is one of the ways that I've found you'll be sure that the changes you made on the user data script will be enforced. So we finished debugging our Nginx, and also we've terminated the old instance that used the wrong user data. So the reason why we went to this step is because we could SSH into the instance, which meant the SSH was set up correctly. Nginx was also running, which means this first step was successful. So the third step is the one that we debugged using journal.ctl to show us the logs of what was happening within the load balancer instance. And then we noticed that we had a bug here that we fixed. We can now rerun the setup to recreate the instance because we just terminated the other one. So we'll run Terraform apply. Once it runs, it will detect that that instance has been removed, and then it will show you that instance has to be recreated. and then the EIP will be updated in place with the new instance data. Then type yes to approve the changes, and then we wait for our instance to be created. Once our IaC code updates, to recreate the new instance, and then you can see the new details here. Let's just recopy our outputs again and update our txt file. So once you update the txt, you can close it. We need to do two things. We need to verify that records resolve to this DNS. That's the first thing we need to do. The second thing is to log into the instance and make sure the Nginx config is set up correctly. We'll just copy this record, run dig, so we can add anything in front of it. Anything like tester dot the subdomain, then we remove the asterisk. If we run this, it should resolve to the public IP of the Nginx instance, which is this one. So let's just confirm that's the correct case. You can see this is the public IP. It's also the elastic IP of the Nginx load balancer. So which means if a user types this in their browser, they'll access this instance. So we are getting an answer from DNS. DNS is set up correctly. The next step is to SSH into our Bastion Host. Then once we are inside the Bastion Host, we need to log in into the Nginx load balancer using the private IP, this one, the private IP of the Nginx load balancer. You will most likely find this error because we previously accessed this IP using a different instance, but that instance has changed. So what you can do is clear this file. So you can just open it in the terminal. You can use any text editor you can find. So you can clear it and then save. You can rerun the SSH command, this one. The reason for the previous error is this server had taken a fingerprint of the previous server, which was using the same private IP. And then when it referenced the fingerprint, while we were using the same IP, it realized that the new server had a different fingerprint from the one that was saved in the non-hosts. That's why we got this error. So we had to clear the non-hosts so that we can recreate the fingerprint for the Nginx load balancer. So this is an error that you'll be getting frequently when you are SSHing across multiple servers. So you should know that the right place to correct this is within this file, the non-hosts. Now we are inside our load balancer. The first step is to go to sudo, and here check the status of our Nginx server. See, our Nginx server is running. The next step is to navigate to the Nginx folder in the etc/nginx/conf.d. While in that folder, we can check our configuration that we were modifying from the user data script. So we can open it using vi. If you haven't installed vi, or if your instance doesn't have vi, you can just run apt install vim. Then here you can see this is the file we generated. This is the upstream hosts from our Terraform local variable. And then this is the redirection for HTTP traffic. And then this is the second server block that now listens to our backend. At this instance, if you try to access this server using any subdomain prefix, it won't load. It will time out because these nodes do not have a process listening on this node port. So we need to set this up. Here you can see this is the location of our acme.sh certificate. So ls with long option, that path, and you can see indeed our file exists. Let's encrypt. Certificate has been generated. So this means we are good to go to the next part of the tutorial where we are going to set up our Kubespray installation. So you can exit the Bastion Host. So a quick fix for the Instance Connect connection is to make sure at places where we have the Instance Connect security group, for protocol we've set it to all using -1 like that. So we'll start with the last Ingress rules. So here for the Instance Connect security group Ingress rule, we set the protocol as -1 instead of the previously set value, which was TCP. We go back to the other Ingress rules. Here for the Instance Connect security group, it has to be -1 like this. This is for the worker nodes. And then for the master nodes, the same. Just look for the Instance Connect security group Ingress rule, correct that one to -1, and then go back at the top. So we are looking for the Ingress rules for the Bastion host. Also, this one was set correctly. You can see it was set as -1. So let's now go into the console and correct our user. So we've made the security group changes. Before we apply them using Terraform, we need to update the IAM policy of our K8 tutorial user. Or we'll log in to our console using the admin user. and then we'll go to the IAM console. Here we'll go to user groups, and then click on the KS tutorial user group. Go to the permissions tab, and then under permissions at the top here, click on add permission, and then we want to create an inline policy. Then here we'll choose service as EC2 Instance Connect. I will be using Visual Editor because I want to show you the actions. Then we need to allow this user, so we'll select effect allow. We go to write. We need to allow this user to open a tunnel and also to be able to send SSH public key. So opening a tunnel and sending the SSH public key will allow this user to be able to use the instance connect to connect to instances within this account. So for this permission, you need to limit it. If you are operating on a shared account, you need to restrict. So for instance, for the two selected actions here, we can limit it to a specific instance. What we can do here is we can add an ARN, and then we can choose resource in this account, and then we can choose region, can choose any region, and then instance connect endpoint. Let's check from the VPC console, and then click on endpoints on the left sidebar. Under endpoints, you'll see the endpoint that we created. You can click on it to confirm with the tags. You can move this upwards, click on tags. You can see this is the one we created, so we need the name, and then paste it there. Then you can just add. Once we add that, we've limited the K8's tutorial user to this endpoint. So the other permissions are for EC2, which we already gave this user full access. So here we need to add this account, and then you can limit the region. You can use any for now. Then for resource, you can use any instance. So when we add these ARNs, we can review our policy in JSON, so you can see what has been added. So the policy name, we'll just call it custom policy, and then create policy. Once we've created that policy, we can test our user now, and we can log back in as the KS tutorial user, and then we'll pick up from there after we have applied our Terraform config. Remember, we made these changes on the protocol, on the Ingress rules for the Instance Connect security group. The next step will be to apply our changes. So make sure you've exported the correct profile for this tutorial, and then just run. Once apply runs, and then it plans the changes. You can see we have 3 changes to make. This one will be to the security groups of the master node, worker nodes, and the Nginx load balancer. So we can approve the changes. So our changes have been applied. We can now go to the console and check if we can use Instance Connect. So we can log back in as our KS tutorial user, and then we can go back to EC2. Then go to the instances. Then here we can select an instance. Let's start with Nginx LB. You can click on connect. Make sure the first tab is selected, Instance Connect. Then select the instance connection endpoint here, this second option. And at the bottom here, you select the endpoint that we are using. Then just click on connect. It will take you to a new tab. Looks like we are in, so the Nginx LB works, and then the next test will be to test one of the worker nodes. Then make sure it's the only selected instance. Connect. So click on the second option which you are using, select the instance connect endpoint, and click on connect. We've also connected into the worker node successfully. We can test lastly with the 2 master node and the Bastion Host. Just select the master node. We'll click on connect. Connect using instance connect. We select the endpoint. We connect. This one should also work. You can see it has worked, and then we have connected to the instance master node. We can also even connect to the Bastion Host, which also has public access. That's also a success. So the instance connect endpoint can be used to limit access of users. In an organization, you can enforce it as a way to ensure any user that accesses your Kubernetes environment is using two-factor authentication, and they have to use their AWS login credentials. You can even limit the instance connect endpoint to only connect to the Bastion Host, and then the Bastion Host can be limited to have no public access. So the Bastion Host can only have SSH access within the AWS account and through the instance connect endpoint. So this is also a nice security approach. You can use that approach. The reason why I spent time debugging this is just to show you how it's set up and how it's done. I know there are easier ways to achieve the same, but yeah, I hope this also helps. Now that we've finished the infrastructure setup, we need to get started on setting up our Kubespray inventory. We will start this by cloning the Kubespray repository on our local, and then from there we will edit the sample inventory and then use it to set up our Kubernetes environment. The steps can be followed as shown here. We'll start by setting up the inventory, fire up our Docker engine, and then run the Kubespray Docker containers. Finally, we'll debug any issues after we run our configuration. Let's get started in setting up our Kubespray inventory. Step 1 will be cloning the Kubespray repository. I believe that's the easiest way to get the files on your local. So search for Kubespray repository from GitHub. Then follow this link that points to Kubernetes 6. This is the one I use. So what we'll do, we'll just clone the repository, click on this icon, and then copy the HTTPS link from this pop-up. And then let's go to the terminal and clone the repository in our working directory. Now that we've copied our Kubespray repository link, we need to clone it on our local so that we have a copy. You open your editor or your terminal in the parent directory of the IaC folder. Can see we have the IaC folder, and then we put it under this parent directory. So wherever you placed your IaC folder with the Terraform setup, open the parent folder in the terminal. Make sure you've installed Git CLI. That's one assumption that I made. And then you can just clone the Kubespray repository using the link we copied from the browser. So this is the link to put it in the Kubespray folder. Once it's cloned, when you open the parent folder, you can see now we have two folders, the IaC folder and the Kubespray folder. Now open the Kubespray folder, and then you can navigate into that folder on the terminal. From here, we need to check out the latest stable release. So remember, the latest stable release from the repository page was version 2.23.1. And just check out the branch that has the latest release, which is release 2.23 there. Now we are on the latest release. So once we have checked out this release, we need to create a sample inventory. What we can do is create a new folder. We'll name it inventory, and then from the Kubespray inventory, look for this folder named inventory. We just need the sample inventory. Copy everything from the sample subfolder within the inventory folder, and then we can leave this repository untouched for reference. Then paste the content copied from the sample folder into the new folder we created, the inventory folder. Now from here, we need to set up our inventory.ini file, which will specify the hosts that we have. We created an outputs.txt file. If you do not have these outputs, so you'll just have to navigate into the IaC folder. First of all, make sure you are using the right profile, then rerun Terraform apply. So just type yes. You can see 0 resources were added, 0 were changed, and 0 were destroyed. This is what you should expect. And then you can just copy these outputs, paste them in the outputs.txt file within the Terraform folder. So now we have a copy of our outputs. The next step is to set up our Kubespray inventory. So close other files and leave the outputs.txt file. And then in this inventory subfolder, this one, the one we created, open the inventory.ini file. And here we have to specify our nodes. We have one master node, which is this one, and we have two worker nodes. Just uncomment the first one, second one, and the third one. For the Ansible hosts, we use the private IPs of our nodes. This is the master node, which comes as the first node. Then we have two worker nodes. We'll just copy the private IP for the first worker node, replace it there, copy the second IP and put it there too. Let's just use the same IP address for the second part. Make sure you remove the comments. So instead of using this, we'll just use the same IP, the same private IP of our instance, EC2 instances. Make sure you use your own values. Then for etcd, I prefer only having the master nodes as the etcd hosts, not the worker nodes. So for the worker nodes, we can just get rid of this. And then you can clean up the file a little. Then we'll be using a Bastion Host to access our private environment. Remember, these are private IPs, and these instances do not have a public IP. So we have to use some sort of Bastion Host to access our individual nodes. You can comment this part for the Bastion Host. let's go back to our output. Our Bastion host has a public IP on which we can access it. So just copy this here under the host, put in the public IP of the Bastion host. And then for the user, this is the SSH username. We are using the default username. Then we need to specify the control plane. Control plane usually contains the master nodes. So since we have one, we'll just uncomment this one, node 1, then we can get rid of the other nodes. For etcd, we'll also have node 1, which is the only etcd member we have. And then for kube node, these are the worker nodes. So we'll have node 2 and 3. So you can get rid of the rest and make sure you uncomment node 2 and node 3. For this one, leave this the way it is and leave the other ones the way they are. We'll be using Calico as our networking plugin. Now, once we have this set up, the next thing is expand the group vars. Inside the group vars, you can look through the various files and see the different options that you can enable. Most of these options have their defaults, but you've been provided with this file so that you can customize these options. Go into the K8 cluster subfolder and then open the add-ons file. And then here, we need to make sure Helm is enabled so that it is installed in our master node. We'll be using Helm to install some tools in the cluster after the setup is done. Under K8 cluster, you can see the version of the cluster that will be installed under kube version. So you can change this and go to the version that is supported by the release tag that we'll be using to run our Kubespray inventory. So the rest of these are basically network plugins. So you can read the Kubespray documentation. It will guide you on how to use these other networking plugins. So once we've configured our inventory correctly, it's time to start our Docker engine to pull and run Docker containers. So once Docker is running, we can navigate back. You can confirm by running something like this on your terminal. Should return this correct response. If you get an error, it means Docker is not running. The next part will be to run the Kubespray container and mount in our inventory. So we need to run the Kubespray container. So we'll be running it in interactive mode, and then we'll have several mounts. So the type of this mount will be bind. Then the source will be, you can see the folder in which we are. So it's the parent folder to the IaC and also to the inventory that we just created. So this one will give us the present working directory. We are copying our inventory from our local. We'll be binding this inside the container that will be running, and the destination will be the root folder, and then within the inventory subfolder. Then we'll have a second mount. You can see our SSH key will be inside the IaC folder and then under the SSH keys. So we need to mount the private key, which will be used by the Bastion host to access the private instances. So this is our private key from the local. The destination will be as follows. So once we've mounted the SSH key, the last part will be to add in the container. So the container comes from quay.io. I wanted to show you how you can get the Kubespray Docker images from quay.io. On your browser, just navigate to quay.io. And then in the search bar at the top, search for Kubespray. On the results, look for the repository that reads Kubespray/Kubespray. Open it. Then you can see the info here of this repository and also the instructions of how you can pull the images. Then go to tags and then look for the latest tag, which is this one. So this is the tag we are using in our Docker command. We'll be running our Docker container using this image tag. We'll just paste in the container. So this version is 2.3. Remember our release under Kubespray was released under version 2.23. Then we need to pass in the command that will be run. Will be this one. So we'll have access to the bash prompt. Just press enter, and then Docker will pull the image if it's not on your local, this image, and then it will start a prompt for you. There are some prerequisites we need to set up inside the container. So the first one, we need to export a few things. We need to disable host key checking. We just need to do this explicitly. I found it helpful. And then we need to increase the timeout of Ansible commands just in case our network is slow. If your network is too slow, you can give this a higher timeout, like 300 seconds. And then we can install this dependency. It might not come with the container. You can see it's already satisfied in this version of the container. Then lastly, we'll have to run our Ansible playbook. For that, you run the following command, Ansible playbook. And then we are setting up the cluster for the first time. So we'll be running the cluster.yaml file, which is in this folder, Kubespray folder, which came with the container. We'll be getting some verbose logs, but not much. So just a single V is enough. This is the username of this Bastion host. So our username will be Ubuntu. We'll specify the private key explicitly. Our private key will be in the root SSH. Then this is the key name that we used to mount the private key for the Bastion host. Lastly, we need to specify what inventory are we using for our playbook. Then in the root folder and the inventory subfolder, and then this is the name of our inventory file. Press enter and then wait until Kubespray finishes setting up the configuration. This process will take a while, so just wait for the first few minutes and make sure the Bastion host can access the private hosts. And after that, you can take a break and keep checking it after a few minutes. Config has been created, so it means our Bastion host is correctly configured. Once Kubespray has finished setting up the cluster, at the end it will give you this summary of what has been done, what has been changed, and what has failed and what has been skipped. So once you get this summary, it means everything went correctly. In case you got any errors like timeout errors due to SSH connections or due to disconnections or timeouts, you can just rerun the same command we ran, this one, the Ansible playbook, and then wait for the cluster to be completely configured. So since we have our cluster ready, we can exit our Docker container. Then we can just quit our Docker engine. Now we can navigate into our IaC folder. From that folder, there is the output.txt file that we saved from our Terraform output. So we need to SSH into our Bastion host. We have our SSH key in the SSH subfolder within the IaC folder using the private key, and then the username will be Ubuntu, which is the default username, and then the hostname we are SSHing into is the Bastion host. So we'll SSH using this command. Once we log in into the instance, can clear the screen here. So we need to SSH into the master node. We check if our cluster was correctly installed. Copy the private IP of the master node, and within the Bastion host, when ULS the SSH folder, you'll notice we already have the default key that we created based on a copy of the keys that we are using here. So we can just SSH without supplying the key explicitly because we already have the default key created. So you just enter the default username for operating system, and then you paste in the private IP you copied from the outputs. Then this way we can log in into the master node. You can also log in into the master node using the Instance Connect endpoint. Once we are in the node, you can just change into root. And then while you are root, you can just run kubectl get nodes, and this one will show you the currently configured nodes. So with this, we can comfortably run our kubectl commands here. You can even get namespaces. You can see these are the namespaces that are created by default. Finally, let's go to the next step where we set up our Ingress controller. We've now set up our Kubernetes cluster using Kubespray. We can now go to the next step where we set up our Ingress controller. Let's start with our setup, and then we can come back later and review this. The documentation for the HA-Proxy that we'll be using can be found at this link. Just go to ha-proxy-ingress.github.io. You'll get the documentation of the Ingress controller we'll be using, and then you can just follow the installation steps here. To install our Ingress controller, we'll have to go back to the master node and then use Helm to install the Ingress controller. First of all, we'll add the HA-Proxy Ingress chart, and then we'll install our Ingress controller from that particular chart. So the first step will be to log in into our Bastion Host. So once you are inside the Bastion Host, we can SSH into the master node. While in the master node, change into root. By default, Kubespray configures the root user to have the kubeconfig, but if you have some knowledge of Kubernetes, you can copy that kubeconfig from the etc directory and put it in the default user home directory. So the default user here was Ubuntu, but we switched to use root. So while in root, confirm if Helm is installed. Just run the Helm command. It should have output this huge menu here that shows you the various commands you can use. And then the first step will be to add the HA-Proxy repository. Just add Helm repo, add, we give it the name HA-Proxy, and then we add the link to the chat. So take note of the link to the chat. It is https://haproxy.github.io/chats. So once we've added the repository, we can list the repositories that we have. Helm repo ls. We only have one repository, then we can do Helm repo update. We've updated our repository, so we are ready to run the Helm install command to set up our HA-Proxy. So for that, just run Helm upgrade. We'll be using the upgrade command, which you can run over and over again in your CI pipeline. So upgrade will allow you to upgrade an existing release, at the same time install a release that doesn't exist, and it can be run multiple times without breaking your CI pipeline. So then we'll just enable install option, because this chat hasn't been installed, so that it will be installed if we are running it for the first time. Then we'll just enter the release name, and then we'll enter the chat where this release will be installed from. So you just enter HA-Proxy-Ingress /HA-Proxy-Ingress. This is the release name we are using. This is the repository that we just added at the top here, and then this is the chat name that is found within this Helm repository. Next, specify if the namespace we are using is not created, we'll be creating it, and then we'll specify the namespace we want to install our Ingress controller in. We'll just name it Ingress controller. You can use any namespace you like, and then we'll be very strict to the version, so that in future you have to change the version manually. We'll use the latest version of this Ingress controller. That's the version that was updated in 2023 September. We have to set a few values. So the first value will be to set the following: controller.ingress/resource.enabled. This one will set it to true. And number 2, we are setting a controller.kind will be a daemon set. Make sure you check the casing and also the spelling. We'll add a third value. This third value will be also from controller.service type. This service type we'll be using will be node port, since we are deploying a BareMetal cluster. And then finally, we want to enable the default backend for HA-Proxy. So here we'll just enter default backend enabled. So we set that to true. When we run this, you can see Helm upgrade checks and it finds the chat doesn't exist, and then since we use the install option, it will be installing it. Now once we've installed the Ingress controller, we can get the HTTP node port and the HTTPS node port using these commands. This is the HTTP node port, and then we can get the HTTPS node port using this command that has been output from our installation step. Then you'll notice this one didn't output anything, and then there is the other option in which you can get the node ports. So just do kubectl get all namespace, the namespace we used, Ingress controller. So this one will show you all the items within this namespace. Then from the service, the HA-Proxy Ingress service, you'll see the type is node port, the one we set on the options. This service is exposed on the node port, which is port 32545, and also for the HTTPS port it's 31542. So we'll copy this node port, then we'll exit the master node and go back into the Bastion host, which is this one. So within the Bastion host, we need to log in into the Nginx load balancer. Use the default username again, Ubuntu, at the private type of the Nginx load balancer. Now we are inside the Nginx load balancer. Change into root by running sudo -i. Then within here we can check the status of the Nginx service. Just run systemctl status Nginx. You can see our Nginx load balancer is running. Then take note, in our user data for Nginx, the file that we were updating for the server is located under etc nginx conf.d, and then the name of the file is default.conf. We want to edit that file so that it has the correct node port. And here you can see Terraform helped us set the private IP of our worker nodes, and you can just confirm the IPs. You can use regex to automatically replace our node ports. So we need to replace the node port from 32080 to the node port that HA-Proxy automatically picked. So this one is 32545, but the one we set as a placeholder was 32080. So we need to change it to read 32545. If you are using Vim editor, hit escape, then colon, then percentage, then S, and then we enter the value we want to replace, which is 32080. We are substituting it with 32545. So just paste the value after the /. We are doing it globally throughout the file. So add another / and a G. When you hit enter, you'll notice the values have changed. So you can see we've changed the value from 3280 to 32545. Now hit escape again, full colon, and then we save the file with WQ. So we are using Vim for this. You can use Nano text editor and find a way to replace those ports. You can even replace the ports manually. Now, once we've saved our file, we need to check if the Nginx syntax is okay. So we'll just run Nginx -t, and then you can see it's telling us the syntax is okay. And then the last thing we do is using systemctl reload Nginx. So once we reload, it will pick the configuration. But if it's a first time setup, to be sure that your setup has been picked, we just run systemctl restart Nginx. This one will turn off the web server and turn it on again. It will cause a slight downtime. And if it turns it off and turns it on again and there is an error, the server will be completely off. That's why we also ran the test command to ensure that our configuration file syntax was okay. So you can run either of these commands depending on your use case. So once we do this, we can exit the Nginx. The next step will be to install a sample application. So let's log in into the masternode and do that from inside there. We'll be creating a new file using VI text editor. It will be sample.yaml. Then from inside this file, we'll just be creating a sample application. This application will be using a Docker image that I built for this tutorial. The Docker image is public, so you can access it also from your end. The first thing we do is create the namespace of the application. We'll just add the namespace block, separate it from the next resource. Next resource will be to create the deployment. It will be using apps version 1. Then the kind will be deployment. Then the metadata will have the following: the name sample app. It will have a label of app sample app. You can use any label you want as long as you remain consistent throughout the configuration. And then it will be installed in the namespace we just created at the top here. Then we move on to the spec. On the spec, we'll be creating 3 replicas. Then the labels that will be matched will be the label that we used here. So that's why you're adding that there. Then under template metadata, we'll use the same label we used for the metadata section. We have the name of the container. We'll call it sample app. And then this is the image you should use. This is a sample Next.js application. And this is the tag that you should use, version 1.0.2. For the port, remember the container runs on port 3000, so you just need to specify that. The next resource will be our service. So service will have this, will be defined using the version 1 of the API. Then kind service metadata will have the name and the namespace. It will share the same name as the deployment. Then under spec will have the selector. This is the label of the application. Any pod that will have this label used on it will be selected by this service. And then the ports for the service will expose port 80, and then it will send traffic and receive traffic from the container on port 3000. So this is the port on the container. So once we have the service, we need to create our Ingress controller. So we'll just add the first part, which is the API and the kind. So the API version will be this one, and then the kind will be Ingress. Then the metadata, the name of our Ingress mapping will be this one, and then the namespace will be installing this mapping will be the apps namespace that we created at the beginning of the file. Then under specification, we'll have the following. You can pause the video and type this slowly so that you capture everything correctly. So we have the Ingress class name will be HA-Proxy, the host name we used. So just copy this without the star and then here just delete the other part, leave the subdomain part, and then paste in the domain string that we just copied from our outputs.txt. The path will be using a path type of prefix, which will be the root prefix, and then the service will be using the service name, and then the port, this is the port on which the service exposes the connection. So with that, we can save our file. Once you've saved our file, you can ls to make sure it's there. So this is our file, and then we can just run it, and you can see everything has been created. So if we go to get all our resources from the namespace named apps, then we'll output everything using the O wide so that we get more details. You'll see we specified 4 replicas, and then 4 pods have been created for our application. 2 of them are in worker node 2 and 2 of them are in worker node 3. Then this is the service that we are using, which exposes port 80, but in the app it listens on the pods on port 3000. And then this is the deployment name, and then finally this is the replica set. Now we are almost at the end of our setup. In this setup, we installed our HA-Proxy Ingress controller from Helm chat, and then we configured our Nginx server to access the correct node port on the worker nodes. Then we installed a demo application. So we created a Next.js application that I've already dockerized for you. The first 3 steps were already done, so you do not need to dockerize the application yourself. So we just use the image that I already pushed to Docker Hub, and then we configured our Kubernetes application, and then installed the application using kubectl apply, and then it's time to test our demo. So on the browser, open a new tab, and then let's go back to our terminal, to our Nginx Ingress resource, and copy the correct app name. So the application name was this one, the one that we set on our Ingress mapping. When you load it on the browser, it should load our application directly from the Kubernetes installation. So this is just a static page with a few links here and there. It means this works. Then one last test before we call it finally done. Let's run an Nginx container and expose it on a different subdomain. We used sample. Let's use Nginx for the next sample application. Then from there, we can close this tutorial. Now let's go to our second demo. For this second demo, I'm gonna do it entirely on the browser to demonstrate how you can limit access to your environment using AWS EC2 Instance Connect. We need to log in into our master node. So while using Instance Connect, you can reach these nodes directly, even if they don't have public IPs. So we can select the master node which you want to access, and we'll click on Connect. The first tab will be the one for Instance Connect. Then we'll be using the Instance Connect endpoint. Make sure you select this option. And then at the bottom here, make sure the username is Ubuntu. Then the maximum tunnel duration, I think for us 1 hour is enough. That's 3600 seconds. And then for the endpoint, if you have multiple endpoints, you can select a given endpoint using the tags that you assigned the endpoints. So we'll just select that particular endpoint, and then we click on Connect. Remember, node 1 was our master node in our Ansible configuration. Change into root. So we'll be creating a second file using Vim editor. So I'll just create Nginx test.yaml. And then in this Nginx test, let's add the namespace. The first entry. The second entry will be the deployment. It will use the following content. Start with the API version and the metadata sections. You can see specification and metadata are on the same level of indentation. Here we are naming our deployment as sample Nginx, and then it will be deployed in the app's namespace. It will be using this label, app sample Nginx. And then for the replicas, for this one we'll have 2 replicas. This means it will be running 2 pods for this deployment. For the match labels, will match the label we specified here. Then under specs, the metadata labels will match the label that we specified here and also here. Then for the containers, we'll just call our container sample Nginx. Then we can use a specific Nginx version with a tag. So this is just a Docker image with a tag, or you can just use the latest Nginx container, which we are doing here. And then for the ports, this image by default exposes port 80 on which the Nginx process will be listening. The next resource will be creating the service. To be using version 1 of the API. The kind of the resource is service. Then the name will be the same as the name for our deployment. Then this will be its namespace called apps. Under specs, it will be selecting any pod that will be having this label. And then for the port, the service can be reached on port 80, and then the target port, the service will be sending traffic to this port on the container. And then lastly, we need to create our Ingress mapping. So for the Ingress mapping, we'll start with the first part, which will be as follows: the API version, the kind, which is Ingress, and the name will be called sample Nginx. Make sure the name is unique. We'll be adding this mapping into the apps namespace. So under spec section, we'll be adding this specification. So for the Ingress class name, it will be HA-Proxy. And then for the host, we'll be using a subdomain of Nginx, and then our root host. For the paths, it will be a root path and then a prefix. Then for the backend service, it will be our Nginx service. So this name has to match our service name, and they have to be in the same namespace so that this resource can connect to the service. And then the port should be the port that the service exposes, this one. So once we have this, we can save our resource. And with this, we can just run kubectl apply. Then with the option F, and then we are applying the Nginx test. Then you can see all the resources are created. The namespace remained unchanged because it was created earlier. Then we have the sample Nginx, deployment, service, and the mapping were added. What we can do to test our application is copy this domain name for our sample app, paste it in a new tab, and then change the sample app to Nginx, which is the subdomain we used. Then press enter. So we are getting a funny error. So you can see there is an error with our container. So that's why we are loading the default backend, and also we are getting a 543 unavailable. So let's go into our container and check why we are getting that error. So what we can do is this. So we can get all pods. Then you'll see our sample Nginx pods are running. And the next thing we can do is check the logs of the pod. You can take one of these pods just to make sure it's working. Let's check the other pod too, the one with D, and it's also working. So let's review our file. So let's just make sure everything is set up correctly. So for the service, target port for the service is 80. We missed something here under namespace, so let's just add that and then reapply our changes. So it seems like the mapping has been created in a different namespace. And then we can just reapply. So now you can see our mapping has been created in the correct namespace. You can get the old mapping from the default namespace because it didn't have a namespace. It was created in the default namespace. So you can get Ingress in all namespaces so that we see which one is out of order. So we expect all our ingresses to be in the apps namespace. That's where we are deploying these two apps. So this one is a duplicate ingress in a wrong namespace. So we need to get rid of this in the default namespace. You can do kubectl delete ingress, and then in the namespace we just say the default namespace like this. Then we need to specify the name sample Nginx. Now if we get all ingresses again, we only have two. One of them points to Nginx service and the other one into the sample application. Then you can just visit this host name to see if it will resolve to the default Nginx page. Our app is running. For the other sample app, this is the domain name. If we reload, we get that. Well, this marks the end of this tutorial. We've created a sample application both on our local using the Bastion Host and also using the Instance Connect directly on AWS. I hope you've been empowered with good knowledge. So in this tutorial, we've covered Terraform. We've gone through how you can set up your infrastructure easily. Then we installed our Kubernetes cluster using Kubespray. And then we installed our Ingress controller and then connected it to our load balancer on EC2. So the successes for this tutorial: you can now set up your self-managed cluster. You can set up your services and expose them on Nodeport. And then finally, you can expose your cluster via an instance-based load balancer. So something to note with that kind of load balancer is that it won't scale automatically. So you'll have to use an instance that can handle your level of traffic. Issues initially for this tutorial we had planned to do an Nginx Ingress controller, but then we ended up using HA-Proxy because HA-Proxy tended to work well with the BareMetal installation. For the Ingress controller, I was getting issues with the load time, so sometimes it will resolve only to one node and then it will reject the other node, so the other node won't connect and it will time out. So there was that issue with the Nginx Ingress controller. But for those who can use it with this setup, it's just a matter of setting up the cluster and then trying the different Ingress controllers within your cluster setup. So a task for you, try uninstalling the HA-Proxy and setting up the Ingress controller. See if you'll get the same issues I got. And then let me know in the comments below. Any questions, any requests, any comments, any views, make sure you comment on the video below, and also you can send me a direct email on support@bloomlessons.com. Thank you and see you soon.